Yeah.
Okay, good. Thank you so much. Okay. This is an outline of my talk. I'm going to first talk about strategies for making the most of the research you conduct during your K award or an equivalent award. So thinking about the first phase of your academic career when you're doing a mentored set of scientific projects. And some of those might be funded by foundations. The K award is typically the one that NIH funds. Others of you might be on VA CDAs, but this topic covers all of that mentored research that we do at the front of our careers to help us establish independence later. I'm also going to talk briefly about the importance of relationship building with project officers at the NIH. And we're going to talk about how to monitor for funding announcements that would fit your work well. So thinking about how to be strategic and applying at places and with announcements that really fit your science. We're going to talk briefly about the Next Generation Researchers Initiative. So NIH has really acknowledged that there is a graying of the R01 workforce, and they've developed some special initiatives for early stage investigators and for new investigators to try to make it easier for you to get funded. And then I'm going to talk briefly about some thoughts about how best to get organized when you're trying to write a grant. So first off, making the most of your career development research. So I would say early on, try to identify at least one question and testable hypothesis that's important regardless of the direction or the significance of your findings. So, a really good research project leads to other important questions regardless of the results. So as you're thinking about your research, you want to be thinking in that framework. And if you can link the papers or the outcomes or the findings from your mentored research to your first R1, that will help you have a strong preliminary studies section. And it becomes a lot easier to defend why the work proposed in your first R grant is important and that it's a logical next step, and why, based on the work that you've done to date, that you're really the best person to have do that work. So another thing that we may not think so much about early on in our career is making sure that you get out front with your research findings and that you start to develop a name or an identity in your field. So how do you do that? You're just starting out, you might just be out of your postdoctoral fellowship. Well, make sure that you're presenting your work at the most important meetings in your field. If you're not sure what those meetings are, that's really where you want to turn to mentors and get some guidance. Take advantage of opportunities to participate in NIH conferences and other symposia in your field. So once you figure out which institute, and we're going to talk more about the structure of the institutes, once you figure out which one is the best home for your research, you want to start looking at what conferences they have. You want to read their strategic plan. They actually pay attention to their strategic plan and think about how your work fits in and helps them achieve their goals. You also want to get to know the most prominent scientists in your field. So I would say don't be timid. If you're at a national meeting and there's a leader in your field, a month before or 6 weeks before, when you know you're going to that meeting, drop that person an email and set up a coffee so that you can run some ideas by that person. If you have a poster or an oral presentation, it's not unreasonable to invite some of the leaders in the field to come to your session. This is a great way to get yourself known and to get some really useful feedback from people. They might have conflicts, they may not be able to come, but don't be timid. When we're in a scientific community, a lot of times we develop ideas together. And so, the sooner you get used to reaching out to senior people in your field, the more you really become a member of that group. It's very important to publish, and to publish as fast as you can once you feel secure about your research findings. So this is really important because you really don't want to get scooped. Usually in important research areas, there are many groups working on similar topics at the same time. And so you really need to prioritize publishing work as soon as it's ready. So I probably say this to all of my mentees, and you may not realize it now, but time is your most precious commodity. So you have to try really hard not to waste time on low yield activities. And if you're not sure what a low yield activity is at your stage and phase of research, you should talk to your mentor or talk to your division chief or department chair, or talk to peers who are a couple of years ahead of you in the pipeline. You want to make sure that you're not spending a lot of time early on in your career doing university service. So you really don't want to be on, PhD student selection committees or intern selection. You really want to minimize administrative work, because the body of research that you can put out there early in your career is really what sets you on the course for the rest of your career. So you want to be aware of who else is working in your area. How do you become aware? Well, you can always do literature searches, looking people up on PubMed. Google Scholar sometimes will pick up abstracts and presentations at meetings that you might not see in PubMed, which is pretty much the Medline indexed work. And you want to make sure that you're following the NIH Reporter. So the NIH Reporter is a publication from NIH that comes out by email, and you just sign up, get yourself on the list. And it will tell you which grants have been funded in your area. So you also need to make sure that you're looking for opportunities to be independent of your main mentor. One of the criteria for awarding an R01 to somebody as a principal investigator is that they've demonstrated that they can be the captain of the ship, that they work well independently. So what are the metrics? How do you show people that you're independent? So in some fields, if you work and publish with more than one senior researcher, that's a mark of independence. So you're not just, totally working in one person's lab or in a subfield that's attached to one person's work, which doesn't look very independent. Or you might have an opportunity to be a principal investigator, like on a small foundation grant in your field, or there are these grants at NIH that are called R21s. Those are appropriate for some investigators, not so much so for others. But the idea here is that you've shown on a smaller stage that you can run the show. So then when you write that first R01, you seem like a credible leader of the project. It's very important early on to talk to your mentor about what you should do now or in the next couple of years, so that when the first R goes in with you as a PI, no one is going to question your independence. So it's never too early to have that conversation and to set sort of a multi-year schedule with milestones of things that you're going to do to look independent. Oftentimes, if a scientist is working in someone's lab and they have bench space in that lab, that the senior investigator is kind of the de facto senior author on all of the papers out of that lab. So you're going to have to really, if you're in that situation, you need to really talk to your mentor about the opportunities that you might have to do some independent publishing of that mentor who runs the lab. And if you wait until the last minute and then notice that everything on your CV has the same senior author, it's very hard to fix that problem after it's happened. So I would say anticipate that and set up a plan so that you're not always publishing with exactly the same senior person. So what about the NIH and relationship building? You want to establish relationships with the program officers at each institute in your research area. So the program officers are really the scientific leaders. And we're going to talk a little bit about the structure of NIH, but the program officers work in the institutes. You want to know the institute's priority areas. How do you learn those? Well, read their strategic plan. Almost every institute at NIH on their landing page has a strategic plan. And when you're reading it, you're really looking with an eye toward where does my work fit in? Now, you might be a person whose work fits in two different institutes, like maybe you do cardiovascular disease and aging research. So you could go to the National Heart, Lung, Blood or NHLBI Institute with your first R grant, but you also might want to think about going to the National Institute on Aging. And so how do you decide where your fit is best? A lot of times, once you've drafted your specific aims, you can set up a phone call with the project officer and run your idea by them. Send a PDF, ahead of time, request a phone meeting, get 20 minutes of their time, and try to get a sense of how enthusiastic that person is for your work and whether it's a great fit at their institute or not. So you can kind of shop your ideas that way. And I really would strongly encourage you to have phone calls or Zoom meetings rather than trying to do all of the communication by email. Because a lot of times project officers will tell you things on the phone that they would never put in writing that might make your grant a better fit for their institute. This happened to me early on. I was pitching a project to the National Institute of Diabetes and Digestive Diseases, NIDDK, and it was a behavioral intervention to improve the self-management skills of older adults with diabetes. And we were going to study a multi-ethnic population. The project officer in my call talked to me about how they had no grants on older Latinos with diabetes and that this was a high priority. She wasn't telling me I had to study older Latinos, but since they were one of my large sampling groups, she just sort of suggested that you might want to focus the whole grant on that group. And that grant did get funded on the first round. But again, that's not something somebody's going to tell you in an email, okay? And this was long before the political climate we have today in the country. But you will learn things on the phone calls that make your grants more competitive that people won't be telling you in emails. So NIH is divided up in two parts. There are the programs, and this includes the institutes that set the research priorities. So yes, get to know your institute's priorities. And then there are the people who do the review. And they're called the Center for Scientific Review, or CSR. These are the people who actually judge your grant. So, how do you get to know your institute? Sign up for the NIH guide and get, the weekly list of funding announcements. And I would say, more recently, most of the institutes have blogs, and, reading the blog in your area will oftentimes be a good way to get to know your institute. These are just some resources for you. So when we think about, NIH program staff, okay, they are not the people who make the decisions about funding. Okay, the program director or project officer works for the institute or the center that might be the best fit for your research. They handle those pre-application questions. So when you're trying to decide on fit, when you're trying to decide on the best institute to apply to, they're the people who do that. On the post-award time, they manage the grant portfolio. So they may have hundreds of grants that they're the contact person for. They also are the people who develop the funding announcements, whether they're program announcements or requests for funding. And we're going to talk about the new acronym NOFO that NIH has just started using and what that means. So the project officers can go to the study section meetings. They're not required to, but if they come, they're observers. They don't talk, they sit on the perimeter. They also are the people who handle post-review issues, and they are the people who will send you your summary statement after the review happens. So there's a lot of acronyms when you're trying to get funded, many different institutes and organizations, and these are just some that you're going to see. And then we have this new acronym called a Notice of Funding Opportunity, or NOFO. So this new acronym was adopted to replace the FOA, or the funding announcement, funding opportunity announcement. And they felt like the NOFO acronym was more descriptive and less confusing. I'm not really sure that's the case, but the way you could kind of think of this is NOFO is the big header, and then there are these 4 primary new types of NOFOs. They're not all new. So program announcements, requests for applications, program announcements with set-aside funds, and program announcements with special deadlines or special reviews. And so you will see all of these, and in the interest of time, since I don't want to step on anybody else's time tonight, I'm going to let you read about these and learn more. But it's very important to know which one you're applying to, and in particular, those ones that have set aside funds, which oftentimes RFAs do too, are the best, because it means they have to fund something in your area. So look for funding announcements, NOFOs that have specific dollars allocated in your area. And if there aren't any, or if the pay lines are really low because governmental funding has been cut, then what we have to do is we kind of pivot to foundations, professional organizations, industry, internal grants at UCLA to kind of tide us over, right? So early in your career, awards from these sources can keep you working, publishing, staying active in the field, strengthening your portfolio. So then when a strong funding opportunity comes by that you can apply for, you'll be ready. If you're on a career development award, the minimum amount of time that you commit to it, from if it's a federal government career development award from the VA or NIH, is 75% full-time effort. The remaining effort can be for research, teaching, clinical work, or other activity that's complementary to the career development award. And usually our institutions like UCLA are going to have to supplement the money that you get in the K award. So there are some rules about salary supplementation, and I would encourage you to read these. I've got the link to the government document that describes these in details. Now, this is a picture of salary supplementation from the NIH, and in blue is the 75% that is directed at the Career Development Award project. The 25% can be from federal, non-federal sources for research, teaching, and clinical duties. When you're making that K to R transition, there's a notice of award to help you think about how your funding should go. So during the last 2 years of a mentored career development award, and I've listed a bunch of them there, the NIH will let you get concurrent salary support from peer-reviewed grants from any federal or non-federal source if you meet the following criteria. You have to be the PI on the competing research grant or director of a sub-project on a multi-component grant. Your K award has to be active when the larger grant that you have the sub-project in, either in the R series, the P or the U, is submitted. And the awarding entity, so the people who awarded your K and the people who awarded the larger grant, have to agree that the arrangement is a good idea. And if that, under those circumstances, then you can drop your K effort down to 50% to make room to be able to be the leader of the project. So there's a picture here about this too. These are common types of R grants. And again, I put a lot of details on the slide, and I put the linkages to the program announcements so that you can come back later and learn more details. Just briefly to talk some about the new investigator initiatives. So what's a new investigator? A new investigator is somebody who has not previously competed successfully for NIH-supported research project other than K awards or the very small research grants like the R03s and the R21s. Or if you've been on a training grant, that's okay. So if you've been on an F series, a T series, or a K series grant. So early stage is defined by the NIH as within 10 years of completing your terminal research degree or within 10 years of completing residency or the equivalent. And if you look at the notice that describes this in more detail, if you've had to take a leave of absence, maybe to take care of a child or a partner, the 10 years can be extended. So there's some really nice breaks in the review process for early stage investigators. They use a separate pay line that's 5 to 10 percentage points higher. So if grants in general from an institute, if they're like going to fund the top 15%, they may be funding the top 20% of the early stage investigators or the top 25%. The other thing that's nice for early stage investigators that if you've requested 5 years, basically all years will be funded unless you're really not performing at all. And so these are nice things that puts the bar in a little bit of a different place so that you're competing against people like you, other early stage investigators, rather than competing against some of the people who are giving these talks today. The early stage investigator breaks only apply to R01s. So keep that in mind too as you're picking your mechanism. The next generation initiative at NIH is committing substantial funding. This started in 2017, and it's about $200 million, ramping up now to over $1 billion to support more early stage and mid-career investigators. And so this is a program too, here's the link about it, that you really want to learn about and see if you fit into this program. So the Next Gen Research Initiative says applications will receive special consideration if you're an early stage investigator and you get a score that puts you in the top 25th percentile. So this would typically, you're either going to be in the top 25% of the pile, or if you have an impact score of 35 or better, if it's a grant that isn't percentiled. So not all grants are percentiled by CSR, but most are for the R01s, and it's one of these two criteria. If you're a mid-career investigator, so you've been out more than 10 years and you score in the 25th percentile, if you can write and tell them that you're at risk for losing all research support, or if you have, a particularly promising stream of research going, you also could potentially be eligible for this. Another program that's relatively new is the CATS R01. And this is for early stage investigators for their first R01. And it could be used also if you're doing a big change in direction. So entering a new or different field. And the CATS R01 says that it requires no preliminary data. I'm going to recommend that you look at this announcement very carefully and make sure you understand what they consider preliminary data, because it's a little bit tricky. And this is something where if you're going to apply for this mechanism, absolutely make sure that you talk to the project officer to make sure you're eligible. Okay, so I'm going to jump to this slide and the next one, and then I'm going to wrap up. So when you're thinking about your first R01, Take a hard look at what you've published and build it around your most significant research. That might be your K research or it might not, okay? Decide where the grant needs to go. Who is your audience? So you need to figure out your institute and the program that you're applying to. Check the NIH reporter. Make sure that the study isn't already funded and underway. You know, this phase takes several months of reading, organizing, writing, and revising. These are the review cycles when you can submit grants. You know, early on, you want to talk to the scientific administrator, that program project officer. You want to outline your grant. You want to be careful, make sure you know the instructions, the page limits, the font sizes. If you make mistakes on any of this, they will kick your grant out of the review cycle and you will have lost 3 to 4 months. Get organized. I mean, for me, working from an outline works. Establish a timeline for completing the proposal. Have the project team meet periodically. Give writing assignments or editing assignments with strict deadlines for your colleagues. Make deadlines for yourself. Find a model proposal. So we have really great model proposals in a library with the CTSI, and you can look at those. Review, pretest, revise, have your friends read your drafts. You know, this is how you get to a fundable proposal. So what do the success rates look like? If we look at first original submissions, which are called A1s, we see that about 10% of grants are funded. So don't feel badly if your first submission is not funded. The important line here is the red line, the resubmission line. And so if on average, if people resubmit once, that 10% success rate bounced to about the mid 30s. They've gotten rid of the second resubmission. And this is why, because the second resubmission no longer seems to be valuable for increasing your probability of getting funded. So just in summary, things aren't going to go as smoothly as this talk sounds, or the subsequent talks that you're going to hear. You need to be flexible, you know, take advantage of unexpected opportunities. So there may all of a sudden be a funding announcement that's a perfect fit for you. And you were thinking you were going to start that R01 application in 6 months. Well, jiggle your timeline and start right away, right? If you can. You want to be very protective of your time. Can't say that too much. And you want to really be strategic. Keep doing the research you love, and then you'll be in the strongest position to submit an R. Okay, I'm going to pass the ball here now. I'm going to stop sharing, and we will have breaks where you can ask questions, and I'm going to ask Dr. Parks to take over.
Okay, thank you, Carol. So I'm going to talk about very similar topics that Carol talked about, and throughout this workshop, there will be some degree of redundancy among the talks, and that's not necessarily a bad thing. In fact, it's a good thing for this type of workshop, because when multiple of us reiterate the same points, you can count on that being something we consider to be quite important. So I'm going to talk about submitting an NIH grant, particularly an R01, preparation and timelines again. I will also talk about reviewers and review criteria. I'm going to touch a bit on the investigator criterion with a focus on early stage investigators, thinking that many of you are fitting into this category. And then I'll complete with a brief presentation on some of my presentation tips. And basically what I'm going to talk about is taking you through this whole process of you preparing your grant, submitting it internally, getting it to the NIH, getting it reviewed, and then back to you. And then I would assume that many of you are on this stage here of transitioning from mentored grants into independent grants, which is the focus of this workshop. So my central recommendation is read other grants, primarily successful grants, but you can look at unsuccessful ones. And when I was beginning my career, this was possibly one of the most important things that I did as I was getting ready to write grants. And then also, as become familiar with the grant submission process, rules and deadlines, not just the NIH, but your institution. So people here are at UCLA or at Cedars, and the institution has rules on submission of grants. As Carol said, give yourself plenty of time. This requires more time than you may think. And also, there's a lot of administrative stuff like letters, budgets, etc. I think you can get these done early and out of the way so you can focus on the meat of the application, which is the research proposal. And very importantly, get feedback from your mentor, your advisory committee, which ideally you have one, other faculty, peers, and this and other workshops. And especially giving written components of your application to others to read to make sure that they can understand it. And in particular, when you're getting feedback from faculty, look for faculty who have actual experience serving on NIH study sections, because they're going to be the most cognizant of what is needed to get an application funded. So first, let's talk about preparation and timelines. And this is the internal part of submitting your grant. And among the things is become familiar with NIH forms. And one thing is identify your group grant administrator. Most likely where you work, there is a person whose duty it is to administer grants. And you should let this person know that you're planning to submit an R1, such as for February of next year, and do this multiple months in advance. And the reason is that you're not the only one in your group submitting a grant, and that you would submit all your documents as PDFs, and then your grant person then uploads it and builds it, but your institution is what ultimately submits it to grants.gov. On here are a number of web pages. I'm not going to go through them, but I invite you to look at these to get information, particularly the NIH reporter, which Carol was mentioning. But I will talk a little bit about this page here on how to apply application guide, which sort of suggests it may be important. So this is what this page looks like. It has links to a lot of useful information on preparing an application. And if you just scroll down this page, you will come to the application form instructions. If you have not done this already and you're planning to submit an R-Series grant, download this PDF and get this document, which is the current one on NIH instructions, and more links here to look at. And if you scroll through this very large document, multiple hundred pages, but beginning on page 82 is really the meat of it, of how to prepare your research plan and other key parts of your application. But not just this section, but others are important. So if you haven't, get this form or this document. Another page to look at that I find to be very important is the parents announcement page. And this is what it looks like. And it begins with the R1, and it'll go down, and it has every type of grant mechanism the NIH has. These are very important documents to look at. It will provide you what the NIH is looking for in this type of grant. And also, and I'll touch on this later, is what it provides instructions to the reviewers on what they should look for in your application. So these are the due dates for submitting a new an A0 R01 for next year. And if the date, like October 5th, is a Saturday, so the actually due date falls to the next workday, which is Monday. But the critical date for you is with the institution. So these are the UCLA dates, which are 5 business days before. And UCLA will publish these every quarter. And then later on the review, it's reviewed, goes, and then funding begins later on. So both the Office of Contract and Grant Administration at UCLA or the Office of Research Administration at Cedars, they're the ones that submitted, and they wanted either 5 or 3 days earlier. So us at Cedars, we have a little bit of a break there. And during this process, one of the things that they're going to be doing is to make sure your grant adheres to all the formatting rules, and it has all the components necessary. I mean, that's what they're supposed to do, and generally they do a good job at that. So what does a timeline actually look like? Let's say you're planning submitting a new R01 for February of next year. So now, and even going back a few months, you should have been thinking, planning, getting the data of what your grant's going to look like. And then from last month to the beginning of Next year is when you'd be writing, getting the feedback, getting all the administrative stuff, and then you would ultimately submit it at the end of February, early January. It would be reviewed in June of next year, and if you got a fundable score, you would get funding by the end of next year at the latest, potentially a little bit earlier. But as Carol was pointing out, most grants don't get funded the first time. We have to resubmit. And realistically, the earliest you could resubmit would be October of next year. That would be reviewed in February of 2025, and you'd get funded in July of 2025. So realistically, we're looking at about a 2-year plus process of getting a grant funded. So things that you need to do, as Carol was pointing out, give yourself plenty of time. I won't go through this slide in detail, but one is present your ideas and aims to your colleagues and do this often. Generate preliminary data that's going to support all hypotheses and publish. And really, this cannot, the importance of this can't be stressed. Again, read successful applications and then get some of the easy stuff done, like the administrative stuff and collaborators and consultants that you need, getting letters from them. These are not onerous tasks at all. And so my recommendation is get those done as early as possible. So these are the sections of an R01 grant. And I think I got them all here, but the NIH is constantly adding new ones. But I think it's relatively complete. So these, the ones highlighted here, are the ones that you prepare or obtain. So you would be getting letters of support from others, file sketches from others as well. These are the sections that I consider to be relatively easy, like letters of support. You don't even write them, you ask for them. And these others are not that difficult to prepare. Biosketch, your biosketch should always be updated and current, so it doesn't take that long to get it prepared for an application. These are the sections that don't differ that much among applications. So for example, your facilities and other resources at your institution is not going to change from year to year. You might have to tweak this for your particular grant for what facilities are you're going to particularly need for your application. But generally speaking, the application, this form really doesn't change that much from application to application. Equipment is equipment, et cetera, et cetera. And others like vertebrate animals, for example, will be modified for every application, but big chunks of it are almost do not change from application to application. So these are sections that you can get complete relatively easily. But the ones that require the most effort are the aims, research strategy, and there'll be much more talk on that. And then the sections on human subjects, if you use that, or vertebrate animals, that may require some degree of work. But by and far, these two sections, specific aims and research strategy, are the meat of the application. So now the review process and how your application is evaluated and what matters to the reviewer. So now we're going to talk about this stage of the grant cycle of getting it to the NIH, to the study section, and then the review. So this is the National Institutes of Health campus in Bethesda, Maryland, a place we all hold dearly. And as you know, the NIH, or you should know, is divided into a series of institutes largely focus on organ systems like heart, lung, and blood, or diseases like national cancer institute, or other priorities such as healthcare disparities. And all of these institutes, with the exception of the Center for Scientific Review, support grants. Center for Scientific Review, as Carol was pointing out, they're involved in the review of most of the grants that go to the NIH, but the institutes also will be involved in reviewing grants, particularly training grants. And that's sort of reflected here, that certain like K-series grants are largely reviewed by the institutes, where essentially all R01s, unless if they're in response to a specific call for applications by an institute, are reviewed by the Center for Scientific Review. And regardless if it's the institute or CSR reviewing it, the mechanism is absolutely identical. It's peer review at a study section. So it's actually, you can review you can influence this process. In fact, you are required to influence this process using the PHS assignment form, where you suggest what institute your grant should go to, and you can suggest a few study sections. And if there's conflicts, for example, standing member on a study section, you can identify that. And if you think areas of needed expertise, of special expertise are needed to evaluate your application, you can identify that. You cannot recommend specific reviewers. And also, as Carol was indicating, there are two people at the NIH that you can interact with, the program officer and the scientific review officer. Overwhelmingly, the program officer is the more important person because they have influence on funding, whereas the scientific review officer does not. So the scientific review officer is really involved during the review part of your application. So reasons to contact this person would be that there's someone on the study section that you may perceive to be in conflict with your application. The program officer is someone to talk to before you submit, to find out if the institute is interested in your work and they would love to support it. And then once you get funded, they will track your progress during the course of your grant. So the program officer is someone that you would likely be establishing a relationship with. And in my experience, these people are always more than willing to help you and provide input. So I strongly recommend reaching out to your program officer when you can and to get to know them. So what about the Center for Scientific Review? So these are the study sections. They review about 50,000 applications per year. So it's the bulk of the applications sent to the NIH. The CSR is organized into over 200 study sections that are largely organ and disease focused. Your typical study section has about 24 members, all from academia. They handle somewhere between 40 to 90 applications. And the key thing is that every application has three primary reviewers. And each reviewer is asked to review upwards of 10 to 12 applications. So that's over 240 pages that they have to read. Just something to keep in mind to make life easy for your reviewer. You can find information at the CSR webpage, and in particular, the roster of reviewers for the study section you're looking at, just in case there may be potential conflicts. And so one thing to know about study sections, they're advisory. They do not fund applications. When you're on study section, you're not allowed to even use the word fund at all. And a video that you can look at on this process. So what are the criteria that reviewers are asked to look at, and how are they scored? So there's two main components on how your application will be reviewed. One are the criterion scores, and the other is the overall impact score, and which is the one that matters. That's the one that will decide the fate of your application. These are the criteria for our series grants: significance, investigator, innovation, approach, or environment. And in my opinion, significance, investigator, and approach are usually the ones that drive the success of the application. For our series of grant, the focus is on science and you, and this is distinct from earlier grants in your career, F and K series grants, where the focus is on training potential. So this is a shift in how you will be evaluated. So how they are scored is using this rubric provided by the NIH on a score range of 1 to 9, 1 being the best, 9 being really poor. And then overall impact is it's not the mean of the individual scores that the reviewers give for these criteria, but just rather how they evaluate it. So different criteria are weighted differently by each reviewer. However, the overall impact has to be within the range of the scores they give. So for example, if a reviewer gives scores of 2, 4, and 6 for the various criteria, their overall impact has to be in the range of 2 to 6. So anywhere in between there. But the final thing is the final impact score, which is ultimately presented as a percentile. So everyone in the study section, all members get to vote after they hear about the grant, and I'll just touch on that shortly. And then it's a mean of all those scores multiplied by 10. So you end up with a final number of 10 to 90. And then that is percentiled against all applications across that meeting and the 2 previous meetings. And so how your grant ranked relative to all other applications that were reviewed. So now just go through the review process of how it's done. So people on the study section will get the applications about 6 weeks before. A week before, they are to upload their critiques and their scores, and that's the 3 initial reviewers. As I just pointed out, each criterion is given a score, but these are not discussed at the study section, but you get to see it in the summary statement that you will get a week or 2 after the study section. And then each reviewer gives an application an overall impact score of 1 to 9. And I just described how that is not the mean of the criteria scores, but whatever they want. And then these become available to all committee members about a day before the meeting begins. And then based on the initial impact scores by the 3 reviewers, the bottom 50%, so the applications that were the bottom half, based on the initial scores, are not discussed, so, or triaged or streamlined or words that are used, but not discussed is the official NIH term for that. So then there's a meeting. So these are in-person meetings now. This, I believe, is a room at the Holiday Inn at Chevy Chase, where I have spent many days. And so it begins at 8 a.m. Eastern Coast time. So for us coming from the West Coast, it's rather early. And it's a cramped room full of laptops. And what happens is that grants are reviewed now in a random order, and the assigned reviewers state their initial impact scores. And the primary reviewer then summarizes the grant, followed by the secondary and tertiary reviewer, and then it opens up for discussion. After that, then there's discussion of human subjects and vertebrate animals, basically saying that they're okay, and then it's open up for scoring for all members on the study section vote. And then other things are discussed after that, such as budget, things that don't impact the score. And then finally, after the end of the meeting, the impact score and percentile are generated. That's later. So this process here of discussing it, these 5 bullets here, typically takes about 15 to 20 minutes per application. And generally, the really good ones take less time. So again, review criteria. What are the things that the reviewers will look at to establish their criteria and scores and overall impact scores? So here are various links that discuss instructions to reviewers. Rigor and reproducibility is a big thing. I'll talk about that later and the significance. But in particular, you should look at the parent announcement page, which I highlighted before. So if you look at R01, the page for R01, you can scroll down. And there are these 2 sections here, applicant submission information and application review information. I highly recommend that you download this PDF and look at these. This section in particular will show you what the NIH wants reviewers to look at in your application. You should be aware of what those criteria are. So again, these are the R01 grant sections, and these are the ones that the reviewers are going to really care about to look at. But these are the ones that really drive it. And in particular, again, it's specific aims and research strategy and BioSketch probably tend to be the ones that really, really drive how your grant is evaluated. And then also just to talk a bit about the early stage investigators. So the NIH says that we should put more emphasis on training and experience. Publications are important, but not critically so, the NIH tells us. So you get a bit of a break with productivity, but I would say just a bit. But still, the quality and relevance of publications are quite important. And the reality is the number of publications do matter because your competition may have more. So as Carol pointed out, and I will stress, it's really important to make sure that you're publishing on work related to what you're writing your grant on. There's also a pay line handicap that varies a fair bit by institutes. I get my grants from Heart, Lung, and Blood Institute, and it's a 10% handicap, which is among the most generous. So what is the success rate for early stage investigators? And so I downloaded some recent data last week, and it's a little vague, I'd say. So this graph here shows that established investigators have an edge over new investigators. So new investigators does include early stage investigators, but it's a bit of a broader term. It means anyone who hasn't had a grant before. I'm surprised that they still use this term because they've been migrating away from it. But they're showing that it's still a gap here. One thing is success rates in either group does not differ by gender. But then here's some other data I also downloaded from the data book, and it shows a different story, a more optimistic story for you, I should say. So if we, the red line is the success rate for established investigators versus new investigators from 1998 to last year. And if you look back at the success rate at the beginning of the century, there was a sizable gap in the success rate. But if you look at it more recently, now it's more equivalent. And that is my understanding. My understanding is other data I've looked at have pointed out the success rate of early stage investigators is essentially the same for established investigators. So that previous data chart I showed, I think is a little misleading. So another criteria to talk about is independence, and Carol was touching on that. So the NIH rules and the Center for Scientific Review rules are that this is not a review criterion. It cannot affect scoring, and you cannot even discuss it. Last time I was a member of study section, we would have our hands slapped if we talked about independence. So those are the rules, but the reality is it's in the reviewer's mind. And so if you remain associated with your mentor, I recommend including a letter from your mentor confirming your independence, and don't include your mentor as key personnel. That helps it show that you're moving on. And don't say your lab space is in Dr. So-and-so's lab space. Say it's in the department of whatever. And I also recommend if you get a letter from your chair indicating their commitment to you, and again, your independence. All right, and then finally, presentation. So I won't go through this in detail, but you can look at the guidelines from the NIH at these links. But one thing is when you're submitting your documents, and these are the ones you have to prepare as Word documents, convert them to a PDF first, so any formatting, figure placement will not get screwed up. And one thing is no typos. And so two books that I recommend is Strunk and White's Element and Style. This was originally published in the 1930s. You can download it for free. It's very short. It helped me a lot in how to write clean English. And then Barbara Gastel's and Robert Day's How to Write and Publish a Scientific Paper I also found very valuable. I run the PhD program at Cedars, and I provide this to all our students. And so some things: excessive use of abbreviations, bad thing. You're taxing your reviewers on things that they have to remember. So avoid that. Avoid vague terms like effects and influence. Use more directed verbs like it stimulates, it represses, and avoid pleonasms, which are just excess words. For example, insulin has been shown to regulate glucose levels. Just say insulin regulates glucose levels. It's much easier for the person. And clean, concise English. These two books really stress that. And an active voice is better than the passive voice. And be clear in your language. Paragraphs and spaces. Don't make your grant look dense or cluttered. So reviewers will look at your PDF of your grant, and if they see page after page that looks like this, they will hate your grant before they even read a word of it. So have spaces between paragraphs, figures when needed, and just make it look more approachable. So, and there should be a logical flow from sentence to sentence, paragraph to paragraph. And basically you're doing the work for your reader, your reviewer, taking them by the hand and guiding them through it. And, some system to outline sections and subsections, but be simple and clean about that. And again, just read successful applications. That will really help show you what it takes. So that's it. Thank you.
Thanks so much, Dr.
Okay.
Parks. We're going to quickly pivot to Dr. Moin for her talk, and then maybe we'll shave 5 minutes off our break so we do have a Q&A. And there's one question in the chat that I answered. If others have questions they want to put in the chat, I can kind of answer some of those in real time. But go ahead, take it away, Tannaz.
Thanks so much, Carol, and good morning, everyone. It's a pleasure to be here. So as prior presenter said, there might be a little bit of overlap, but we're going to take an additional sort of viewpoint of tactical approach to writing your proposals. And as you've already heard this morning, I think time is your greatest commodity, as Carol mentioned, and this is writing grants is something that you really do need to put the time in for and really do advanced planning. And I would say 4 to 6 months is probably on the conservative side if this is your first R01. There really are a lot of pieces. And so, creating a timeline, a list of tasks to keep yourself organized is going to ensure success. So it almost goes without saying, but it's important to say, obviously pick a high impact topic that you love and you're excited about. This is months of your time, and hopefully the grant will be funded. So years of your time. So this really does need to be something that you're truly excited about, and that will come out in your writing. And of course, ideally would be a natural extension of your K work. We'll talk a lot more later today about drafting the specific aims. I think this is probably the most important piece. You'll start here very early on, and you will come back, and this will be an iterative, the one page that every reviewer is going to read on study section. So you'll start here and you'll come back to this at the very end. But also thinking months ahead about your scientific team, and at least for health services and clinical trials, the teams tend to be larger, multidisciplinary. And so really thinking about how to put those pieces together is going to be important. Meeting with the administrative team, as you've heard, there are deadlines that are internal to UCLA and our affiliates. So really thinking about the calendar and mapping out the tasks. There are all of these small documents that don't take a lot of time, but if you haven't done them in advance and it's your first time, making sure that you've done them correctly is going to be really important. And starting to get drafts to your co-investigators. And again, thinking about if you have physician scientists on your teams, what their other commitments might be, and of course the commitments like vacations, hospital attending for any of your team members. And it's important for us to just highlight the CTSI does have grant studios. So if you're able to join any of those, in addition to these workshops, I think would be a good resource to be thinking about. So 3 to 4 months out, you've already heard about the importance of building relationships with your program officers, your program officials. So I think this is something you definitely want to be doing ahead of time. Remember that program officers tend to love the idea of seeing their K awardees really, be successful with the K to R transition. And obviously your relationship will evolve. It's possible you might be interacting with a new program official as well, but really asking if they would be willing to read your specific aims. Again, you've already started working on those, you've been iteratively going through drafts for at least several weeks before you would share this with the program officer. But I know that in my own experience, the advice that I've gotten has really been incredibly important. And in addition to what they think about your aims and suggestions they might have, actually specifically asking about study section. This is also a really important learned lesson for me, where I've gotten advice from the program officer. I was thinking about a particular study section, and they helped me understand why that actually might not have been the best choice, and really thinking through those options with them. Your cover letter can mention conversations you might have had with the program officer. And of course, remembering this is about relationship building. It's not just this first RO1, hopefully many RO1s to come. So sending thank you emails and then following up your correspondence afterwards is really important. So putting together your team, again, you want to be thinking both as with your reviewer hat on, as well as your PI role. And again, in health services, I think we tend to have larger teams. We are very interdisciplinary. So really thinking about the expertise that you want to bring in, but making sure that the contributions of the team members are unique and they're not overlapping. So it really is like a puzzle that you're trying to put together. And, in addition to the individual team members that you're bringing in, really thinking about the strengths of your institution. So that environment, the resources are things that, at UCLA and the broader set of affiliates, we have a lot that we can showcase. So thinking about the CTSI, our research cores, individual department and division strengths, those are things that you want to also highlight and discuss and really create a nice roadmap for how you put it together for this specific proposal. In thinking about your team, don't forget about subcontracts. So if there are investigators outside of your institution, there's sort of an additional layer of budgets and administrative review that needs to be done. And these typically add time. So, for our proposals, so several of the projects that we're currently leading have subcontracts with other large healthcare systems. So we want to definitely make sure to put in several extra weeks for those. You want to also be thinking about seniority levels. So we've talked a lot about, sort of independence and making sure that you are, not always working with the same senior folks, but also just remember not to be top heavy or bottom heavy. So you really want to balance representation of the levels of seniority in your team members, and thinking about your division needs, future directions you want to go, as well as you consider putting together your team. And the last bullet here, really choosing people you want to work with. I cannot emphasize this enough. I mean, you're going to be spending this grant, hopefully it's funded, you're going to be spending 5 years on this project if it's a 5-year proposal. So make sure these are individuals that you are excited to work with, and that that the team is going to gel together very nicely. Developing your leadership style is really important, and this is something that you will grow into, really embracing the role of PI, obviously moving away from the K sort of career development mentality. You want to emulate PIs that you admire. There are also really wonderful formal leadership training opportunities here at UCLA and with our affiliates, so think about those. And as this is the case of being any type of team captain, really making sure that everybody on your team understands their role. So setting expectations is important. What is each individual team member contributing? How many meetings do you want them to attend? Are you having in-person meetings or virtual meetings? What % of their time, of course, needs to even, those details need to go into your budget justifications. And, at the grant writing phase, it might be a little bit early, but even starting to think about authorship and sort of how papers and roles will play out. Again, the earlier I think that you can have these conversations, the better off you'll be. Your needs will be met, and your co-Is and your team, everyone will know sort of what their role is. We'll talk, I think, also a little bit later about budgets, but again, this is something to start thinking about early. The R01 budgets are obviously a lot bigger than the K budgets, so there's a lot more to think about. There is a tension between being, sort of economical and practical. And this is where, again, conversations with your program officer might be helpful, but definitely senior mentors and your co-investigators will have advice that they can offer too. The agencies, I guess the general thinking is they like lower budget projects. To be honest, when we do grant reviews, we're not really scoring the budget in any way, but whatever the budget is, it needs to be realistic and reflective of the work that you're going to want to actually get done. And do anticipate budget cuts. These are not unusual to see. I think they're kind of more common practice. And obviously budget justification is critical. So you really have to justify each dollar and cent that you're requesting. And investigator time, your time, excuse me, typically, 30 to 35% is not unusual for a first time R01. And, remembering again that for your team, if you're 35% and everybody else is 2.5% or 5%, that can be a red flag. So several of your co-investigators really need to demonstrate sort of that they are, contributing more than 5% and actually part of the work that's going to be done. Again, just a reminder not to under budget. There are, again, many, many pieces, and we, again, the more time you give yourself, the more thoughtful you'll be about thinking through these pieces. But obviously you want an experienced project director. So they have salary, there's grant transportation for staff, cell phones, translations, transcriptions. I mean, I listed a few things that I think sometimes we might overlook, but these are really important things to consider. And as you see other examples of grants, this is also something you'll want to look out for. So writing your grant, we'll talk later about approach and really the methods. This is also a very, very important. It's interesting, the NIH just announced that they're going to sort of streamline the review process. And instead of having 5 categories, they're sort of condensing into 3, which are importance. The second category will be rigor and feasibility, and the third category is expertise and resources. So they're sort of taking what were 5 categories, condensing them into 3, and that doesn't start till 2025. But remember, the approach is going to be sort of one of those big buckets in terms of scoring, remembering your audience. Many times on study section, there may not be many folks who understand maybe even the clinical condition that's being highlighted. They know nothing about your research. I think you should just presume that. And so you want to really make it as easy as possible on the reviewer to understand, sort of why this is such an important topic. It's a timely topic, and really thinking about figures, tables, colors, and making it engaging. So this is your story to tell. And hopefully, again, if it's a natural extension of the K work, there'll be preliminary studies. This is a requirement for the R level grants to have some prelim data. And you really want to show the reviewer your team has the experience to do this project, right? So this is why this team has been brought together and why that you're sort of in the unique position you are to do the proposed work. It's also really important to show the reviewers that you've considered, right, the potential obstacles, the trade-offs, that you've been very thoughtful, right, in the approach that you are suggesting. So what are some trade-offs of your sort of major study design decisions, as an example? And so these are, again, really important pieces of the approach that you'll want to spend as much time on as possible. And again, going back to make it as easy as you can for the reviewer. They're reading hundreds and hundreds of pages. So using exact language to reference the program announcement, referencing the institute strategies, reminding folks, sort of how your project addresses key review criteria, and again, the bulleted sections, and making it as easy to read through. And this is my last slide, just in terms of common pitfalls. So you want to write the abstract, and I would say really the aims early and try to circulate that. Don't be over ambitious, don't over promise. Be careful about that. That will come up in your feasibility scoring. I think reviewers are quick to pick up on that. And then again, you have to convince the reviewer that this is the best team. You've got the preliminary data, and you've thought through all the alternatives, and then that you have the institutional support. And I absolutely agree with making sure that your chair, there's a letter about the commitment that could be included. Last but not least, have fun. And I have a little infographic here, sort of the board reviewer and the engaged reviewer. But if you're excited about this, I think it comes through, and you really want to make sure that your proposal is easy to read, and that you can get other people excited about the things that you're excited to work on. That's really the ultimate goal. So I'll stop there, and I think we're going to have a few minutes for questions.
Thank you so much, Tannaz. And again, if people wouldn't mind turning on their camera when you ask questions, and telling us who you are. And I don't see any questions in the chat, so if you raise your hand, I can call on you. So let's use the hand raising function, and again, just briefly introduce yourself and tell us which of us you'd like to direct your question to. Okay, Dr. Wilson?
Yes, Dr. Mangione, thank you. I'm Rajitha Wilson. I am a assistant professor and child neurologist in Semel. Dr. Elashoff is one of my primary mentors for my K-23. I have submitted some aims for a review at this workshop and plan to, fingers crossed, submit an R01 in February. And first, Dr. Mangione, this question is directed towards you, and I apologize. I was switching devices around the time you were describing, but I did read the slides last night and caught most of it, describing sort of if you were to get an R when you're still funded on your K, the last sort of year 4 and 5, how you might be able to reduce effort on your K itself. And my question to you was, I think there was a note in the slide that they would also then adjust your salary potentially. So I think my question was, are you saying that they would give you potentially less support from that perspective for your K, for your salary?
Yeah, so the way the notice is written, they could do that. I can tell you in my experience over the last decade, they seem to never do that. And I think the reason why is because once a year is awarded to an individual, if the agency takes that money back, they can't really use it for anything else, is kind of my understanding from talking to project officers. So I think it would be very unusual to have your stipend reduced if you dropped your effort to 50%, so that you could spend maybe 20 or 25% PIing an R grant in your final 2 years.
Okay, thank you very much.
Other questions? Dr. Essien.
Thanks, Carol, and everyone for sharing your remarks. My question was going to be for Tannaz, but also for others in the room. And I think I've had a similar question in the past. And I'm Utibe. I'm a general internist and assistant professor in GIM. So Tannaz, you mentioned that reviewers like supporting their former K scholars, and as someone primarily VA based, has a VA Career Development Award. I think I'm going to be like totally new and to these NIH reviewers and institutes. I'm curious, in your experience in particular, how that looked like. Do I need to have some kind of smaller NIH based grant before I submit an R, or is that not something that I necessarily need to be thinking about?
Oh, such a great question. So I think the CDA, we really see it as a K equivalent. And of course, you would say that in case there is a reviewer who's never heard of a career development award in the VA, but I doubt that will be the case. So I think the only potential disadvantage of 2A is you might not have had that relationship with a program officer, right, as part of the K, but that's something you want to build as part of the R planning. So I would say, the idea of the K to R and folks being enthusiastic about it, I think some of those principles will still apply because you are, the idea is we have a junior amazing investigator and we want to sort of continue to support them. But that relationship building with the program officer is just something you want to do maybe a little bit earlier. But I think you're going to be in good shape. So I wouldn't worry too much about that. And of course, the preliminary data, it could build on the work you've done in your CDA as well, right? I actually, having sat on both VA and NIH study sections, I'm surprised now on the NIH side to see more and more VA-based applications. It's not unusual to see.
I think the only one small thing I would add is that at most of the institute, there's one project officer who does all the career development awards. So it's very likely that once you submit an R, it's going to be a different person anyway.
Yeah.
But it is a small community, and they do see it as a success if one of their funded K awardees gets an R. But I think other things count so much more. In terms of the review process and, your own track record of independence and the importance of the ideas you're proposing. So, I think I would think of it more like one tiny factor, not a deal breaker. Next question is with, go ahead, Scott, please.
One point I would make though is that although it may not be that important how much the program officer knows who you are, it really is helpful if the study section members know who you are. So it's extremely important to get out there. In other words, present your work at meetings, hopefully at meetings where members of the study section will go, because it really, really helps if they know who you are and they think, oh, this is a good guy and he's done some really interesting work. And they've actually maybe even heard presentations on your preliminary data. So it's extremely important to go to meetings.
Yeah, and I think the one thing I would add is don't be shy about inviting a program officer to come to your talk. So the way that I met Judy Fradkin when she was head of the diabetes branch was I invited her to a talk that I got at the ADA. And afterwards we had a cup of coffee, and so again, did that make a difference in the long run? Well, definitely not if I didn't write a very good grant, but, I think sometimes if you're just right on the bubble, sometimes at council where ultimately the funding decisions are made, a project officer can open their mouths and advocate for you at council. They're not part of the review process, but they are allowed to talk at council.
I'm poor Roy. We're going to let him get to his question in just a minute, but I can't stress that enough. Actually, the main scientific meetings, you mentioned ADA, Carol, the program officers are there. So I've actually had them email me after, I didn't know they were in the audience, but they will email me and say, I was there. And so that's also an opportunity to connect with the program officers. And if you're there in person, that's, a great opportunity as well for the coffee and talks.
Yeah, and I think, what you can do is you can just send a cold email. And you can say, I'm giving this talk entitled blah, blah, blah. My mentor thought it was something that you might be interested in. Here's the session time. Not even sure you're going to be at the meeting, but, I do plan to be writing a grant for NIDDK soon. And I just thought you might be interested. And then you may not get an answer, you may get an answer, they might show up, they might not show up, but you haven't hurt yourself, So I just think, again, it's interesting to me how so few people are proactive that way, that actually, if you are, you'll be remembered, so you can do that. Go ahead, Roy.
Oh, thank you. So I am a TBI researcher at the University of Southern California. I finished an institutional KL2 through my CTSI, and then I had an unfunded KO2, and sort of trying to carve my path forward towards an R as an ultimate goal. And so in this kind of path forward, I don't really think KO2 is kind of the way forward for me. So I wanted to know your perspective. Does it matter, how you get to the R with specific examples going through, a large foundational grant versus going through industry versus going through DoD, for example? Are the different paths towards an R looked at differently? Thank you.
So I'm going to ask Dr. Moin to answer this question because she had one of those different paths.
Yeah, I didn't have a K, I didn't have a CDA. It was just, so I think all paths are okay. And I mean, I don't know what else to say other than I think it's really just important that you have the preliminary data, which is a requirement for the R, how you got that or where, how you were able to set that up. And of course the team, but my own journey to my first R01 and then the ones that came out, it wasn't typical by any means. So please don't let that deter or discourage you in any way. I don't know, Carol, if you want to add anything. I think we have a lot of example of folks.
Yeah, no, and I think, I mean, when I think back to your example over a decade ago, part of what you were able to do to have good preliminary data was that you ended up playing a big role in some multi-site studies. One where you were the lead investigator at the VA for a consortium of many VAs that were working on your topic. Others as the lead endocrinologist on a multidisciplinary team on the UCLA side. And, I think the main thing is to be able to do the research that you need for the preliminary studies. And, if it happens more in the framework of being a participant on a big study where there's clearly a piece you're going to be able to be the first author on and lead on, or if it's in the form of a career development award, the main thing is to get the preliminary data done, and hopefully somebody at your institution, either your chair or other people, are supporting you to do that work, regardless of whether you have a formal career development award.
Another consideration is if you're not a U.S. national or a green card holder, you are not eligible to submit for certain KFT grants.
Right.
And so I would sort of also agree that it's not laid out that you have to have a track record of previous funding. It doesn't hurt, but it's really for the R01, it's going to be publications and the data that drive it.
And I think I'm glad you brought that up because, I think, Bill, that a lot of our people who aren't eligible because they aren't citizens, sometimes they can get like an R21, so sometimes there will be smaller grants. The R03 or the R21 might be something that could support your work since you're not K award eligible. And we certainly have had people in my division who've gone that path. Other questions? We could take one more question and then I think we'll do our 10-minute break and come back at, 9:40. Any other questions?
I'll ask a quick one. And if it's not quick, happy to table it for later too. How much should you signal sort of your K and your R01? Meaning if you do have some good preliminary data from the K, you've had a publication, just a couple sort of comments on that and then really move to how that R01 is different, even if it's building on that, or just use it as a separate.
I'm going to suggest looking at examples in grants. Bill mentioned this, and we do have like a library of funded grants from the CTSI, because a lot of it depends on how linked it is. If your K award, in a pathway of science, if the K award provided a really critical piece of information for how you framed the subsequent study, then you're going to want to give that finding more real estate. You might even, with the publication, you might cut out like the main table and put a piece of the main table into the body of the grant. Don't assume anybody's going to have time to go read your papers, who are your reviewers. I mean, these reviewers are volunteers, as Bill mentioned, and many of them are just got off a transcontinental plane. I mean, when I was on study section, it was always getting off the red eye because I had little kids at home and it would make the day shorter, so I read a lot of those grants on the red eye before I showed up at study section. So, it's always great to have a beautiful table or a beautiful figure that breaks up the text. And, if that's coming from a key finding of yours from your K award, great, make a lot about it. If the work in the K award is mainly to show that a technique or a statistical method, maybe that just deserves a sentence. So it really, I think the amount of real estate you give it really hinges on how important was that piece of work for what you're proposing now, and how much did it prepare you for what you're doing.
Okay, that's very helpful. Thank you.
Others, anything to add there? Okay, let's take one last question, and I'm going to butcher your last name. So why don't you just introduce yourself?
I'm Christina Puigsaus.
Thank
I'm an assistant professor in Hmong. I do basic research. Well, I mean, not really basic, it's translational research, but I develop cell therapies and then do clinical trials as well. And so I have a question regarding the ESI status. So I became junior faculty and 2 weeks later COVID started, so I was not able to hire anybody. And so now I'm submitting my first R1 and I'm gonna lose my ESI status soon, meaning that it's gonna be 10 years after I got my PhD. And I don't know if it's something that I should be kind of like, I know that there's COVID exemptions and things like that, but I don't know if this is something that I should be pursuing or I should just ignore it and assume that this is.
I'll have other people answer too, but I think COVID is a highly unusual thing and it set a lot of people back. And I think it would be perfectly reasonable to reach out to the project officer with a letter explaining how you lost a year, on your work, and that you would like to know if you could have an ESI extension. It never hurts to ask, right? The worst thing they can do is say no, right? But I don't know if anybody else has opinions about that.
It's just because
No,
while I was at home, I was able to write a lot of grants. So that was good because I got a lot of grants. So in a way, it helped me in a way, but in the other way, it kind of delays the way you progress, right? So that's why I don't know how to justify that. That was mine.
Bill, you were about to say something?
No, I would agree. It's absolutely seek the extension. And if you get the extension or not, if you submit an R01 within your ESI status and you have to resubmit, you're still on as an ESI. You're grandfathered in for that application.
Nice.
And there may be time limits on when you have to resubmit the revised application, the A1. I'm not certain, but that's one of the reasons to contact a program officer. I think the program officer also would grant the extension for status, right? They're the ones that have that power.
I see. Let me make sure I understood that. So if you submit your A1 while you are ESI, and then you have to resubmit, but you are not.
No. You submit the A0 application, the first application. Yeah. If you submit it the day before your ESI status is up, and then you have to resubmit it, you're still an ESI. That grant was submitted by an ESI.
Thank you.
Right.
All right. I am going to have us take a break. So let's come back. Let's see, we're at 9:34. Why don't we come back we're a little behind. Let's come back at 9:40, if that's okay with everybody. Okay, we are back, and I'm going to go ahead and have Bill get started, and you will be followed by Scott right after. So,
Right, okay, and I assume you can hear me. I can't see the controls on your screen.
we can, yes.
Okay, good. So I'll talk about significance and innovation, and this is, even though I have 30 minutes or 25, this takes much less.
Yeah, you have 25, and then Scott will be coming behind you on the same topic for 10
Yeah.
more minutes.
Yeah, this talk is always way shorter than I'm allotted.
Okay.
Anyways, significance and innovation are two components of your grant applicant, of an R01 grant application, according to the NIH rules. In addition, they are two of the scored criteria that impact the overall impact, as I talked about earlier. One thing is that beginning in a bit more than a year from now, the NIH is sort of, what they're saying is simplifying their review framework. So currently, significance and innovation are scored criteria. They will remain so, but they're going to be pulled out to evaluate the importance of the research. And it looks like the NIH is really is going to emphasize significance in particular, because a key question in their new review process is, should the proposed project be conducted? And so I would say significance and approach, which I'm not going to talk about here, are really going to be driving it. So significance of your project is really a critical consideration, and you need to pay a lot of attention to it. First, I'll talk about innovation. And in my opinion, innovation is much less important than significance. These are the instructions from the NIH to reviewers on how to evaluate innovation. There is nothing surprising here. Is it going to do something new? And so basically, innovation comes in two flavors. One is that you're going to propose new concepts or challenges to existing paradigms or dogma. Or two, it's going to be technical, develop new reagents, assays, technologies, practices, whatever. So that is what innovation is. The NIH has said proposals do not need to be innovative. I find this to be an odd statement, because we should always be proposing something that's new and is going to provide some new information. So I think grants have to be innately innovative. So based on the NIH, it's not a review criteria. And in my experience, this has not been a driver of why a grant gets funded or not funded, but it can still be a big plus if you do have some innovative strengths to it. And just as a side, if anyone here is thinking of applying for K applications, innovation is not a component of that. In fact, it's not even mentioned in instructions for K awards. So my advice on preparing the section on innovation for your R1 is, one, keep it short, 1 to 2 paragraphs at the most, or maybe a bulleted list, one or the other. There are no datas or figures in this section. And 2, be realistic. And here's an example of the innovations section I had in a R01 I wrote a few years ago, which was funded, and you can see it's very brief. And something else I find from my time on being on study section and chairing study sections is that what the applicant writes of their innovative strength seldom agrees with how the reviewer assesses it. So I've always found that to be somewhat ironic, but that is innovation. So more important is significance? And these are the NIH instructions to reviewers of what significance is and should be addressed. And so in part is are you addressing a critical barrier in your field? And another element of this, which I will talk about, is rigor. And rigor is something that is being really emphasized to how we both prepare our applications and how our applications are reviewed by the reviewers. So I will talk a bit about rigor in this presentation. So first off, what is significance? Well, one, it is not related to the disease or cellular process you are studying, because after all diseases are significant, and basic research can have an impact. What significance is if the work that you're proposing is achieved, if you accomplish your work, will you provide an advance in either knowledge, technical capacity, and or clinical practice? And hence, the evaluation of significance as a review criteria is impacted by the research approach. And so a wet lab proposal that is descriptive or derivative or collect correlative information will not be considered significant. Now, in contrast, epidemiologic and clinical studies may see associated findings, but the key thing is, will something be advanced and improved by the work that you're proposing to do? And again, there's how the reviewers will look at it is your evaluation of and attention to rigor is a big component of how significance is evaluated. So a misconception, this is related to what I was just saying, is that significance means translational science or clinical importance, or that's disease related. That's not true. And so this is a quote from the NIH that they want fundamental knowledge and that the application of that knowledge will enhance something. So that's why they fund studies with worms and Drosophila, because the fundamental processes are understood. It can have a big impact on addressing human health. So an application does not need to show the potential for direct clinical impact. That's something to be understood. And importantly, you do not need to develop a new drug. Now, even though I put that here, everyone is still going to say in their significance section that their work is going to point the way for developing new therapies to treat disease. And I just usually, if that was the case, we probably would have cured every disease by now, and it hasn't. So one thing, as I was stressing, is rigor is being evaluated. And this is rigor of both the previous work, both yours and that of others. And that is a rigor of the previous work that serves as a key support for you're proposing to do. So that is basically the foundation of the premise for your hypothesis and planned studies. This is the NIH's definition of rigor. It's the application of the scientific method to ensure robust and unbiased experimental design, methodology, analysis, interpretation, and reporting of results. In the research plan, rigor is also a component, and part of that is addressing relevant variables such as sample size, sex, etc. And in particular, sex must be addressed in the approach. And then another component is authentication of key biologics and chemical resources. That is a one-page, basically a boilerplate document that you will include. I won't talk much about that. So rigor is addressed by the reviewers both under significance, so that's really focusing on previous work, and the rigor of your approach as planned. So I will spend a little more time talking about this aspect, and you can find information on the NIH's recommendation to reviewers on how to look at rigor. This is a form that, or a scheme that the NIH provides of the 4 components of rigor. So rigor of the prior research, rigor of the proposed research, the biologic variables, and authentication. These two, number 2 and 3, really fit under the research strategy. Rigor of the prior research would fit under the significant component of your application. But in terms of the significant component of the reviewer's critique of your application, all of these are going to be involved. And if that's confusing to you, don't worry. It's confusing, I think, to all of us. It's taken me years to feel somewhat comfortable with how rigor is addressed. So how do you address rigor in the research strategy of your application? So one is discuss the rigor of the research and data, so both yours and others that form the foundation of your research, and discuss how you will address any weaknesses pointed out in number 1. You should include strategies that ensure a lack of bias and overall robust approach, address relevant variables, and the numbers 1 and 2 would be addressed under the significant section of your research strategy, whereas the others, including parts of number 2, would be under the experimental approach section of your research strategy. So what should the significance section look like? For an R01, which has 12 pages minus the specific aims, I recommend about 1 to 1.5 pages, ideally 1.5 pages for significance. And here you're going to critically review the literature and provide a clear premise for the studies you're proposing. Now, one thing, for an R01 application, most NIH applications, there's no limit on the number of citations. The reference pages have no page limit. And I recommend that you cite original timely papers over reviews when you're talking about the background. I have found as a reviewer, if someone cites a lot of reviews, I just find that to be a sign of laziness or a lack of familiarity with the original research that had led to what their work is doing. And again, address rigor. Use the word rigor in it. Point out gaps and flaws and strengths too of the previous research. And if you agree with something, don't be afraid to say it and explain how you will correct this travesty. And Scott, I know we'll address this in the next talk as well, especially this point of being diplomatic. Also, in the significance, limit your discussion to things, whatever it is, disease, pathways, molecules, etc., that you will study. Don't talk about things you will not study. The importance of this is don't put stuff in the reviewer's mind that they don't have to think about when they start looking at the actual studies and experiments you're proposing to do. And I, as a reviewer, have encountered this. Grants will talk about molecules, and I put those in my short-term memory, and they never show up again. And so I wasted that part, those neurons, just to hang on to those ideas. So keep your application focused. It's okay to show enthusiasm, but it should be tempered. Know your audience. So if there are people at the study section, you might want to cite their papers, and get the reviewers interested. For me, it's actually in reviewing grants, I love the significant sections, especially if they're well written and they present a really interesting idea and gaps to knowledge. So some pet peeves: it's too long, it's not focused, it's not timely nor scholarly, an over-reliance on reviews, uses the word exciting more than once. I once reviewed a grant that had exciting every other paragraph, and it was just too much. Or a poorly developed premise that the argument for the work is not there, and if it doesn't address rigor. So reviewers are specifically required to address this particular point. And then finally, this is my last slide, is just to show you the importance of significance in an application. The first 2 bullet points under here are what the NIH defines as overall impact. And remember, this is the score. This is the score that really derives the success of your grant. So it's overall impact, the likelihood of making a sustained, powerful influence. This is how they define significance: focus on relevance and likelihood of making a meaningful advance if the aims are achieved. These 2 are very synonymous, and that sort of underscores the importance of significance for your application. And remember, your topic is not significance, but rather what you're doing to advance the field. So I will stop there and thank you for your attention.
Thanks so much. Go ahead, Scott.
Okay, great. Let me just get my slides here. There we go. Okay. Hopefully everyone can see this. Yeah, so I am Scott Filler. I'm in the Division of Infectious Diseases at the Lundquist Institute down at Harbor. But I do mainly basic research looking at fungal infections. So let me talk a little bit about this. As Bill has already mentioned, the review criteria are going to change. It's really just a minor change though, because basically all the factors that he mentioned are still going to be included in the analysis. And to be honest with you, most studies that have looked at of all the different scores you could get in all the different subsections, the key part is the approach. And for our grants, the approach is really the score driving score. And if you look, you can get different scores on your significant innovation. But in general, the score that you get on the approach will actually determine your overall score. And then, of course, as he also mentioned, there's factors 3, which is the environment, investigators' environment, and so forth. But remember, the score driving part is really going to be the approach. There are other review criteria that may affect the overall score. So for example, the human subjects protections can affect the score if it's written poorly. That's especially important for health services or clinical trials. The vertebrate animal protections can affect it, so you want to make sure that's in good shape. Biohazards can, and probably a key thing here is resubmissions, renewal, and revisions. So at least in the current scoring system, one of the questions that the reviewer is asked is, has the grant been, if you have to resubmit a grant, has the PI been responsive to the previous reviews? So you actually want to make really sure that you go through your previous reviews very, very closely and address them in the grant. So there's things that will not affect the overall score, and that's authentication of biologic resources and the budget and period of support. Although they say it won't, but I actually think that, for example, if the study section thinks that you really padded your budget, for example, they will frequently give you a lower score, even though that won't be listed as a reason for doing it. So as was already mentioned, you really want to make the budget and period of support appropriate for your project. So the key thing about the significance is you really want to answer the question, why is the research important? In other words, why should they care? And you want to back this up with a strong premise, which will hopefully be the literature, and with luck, also your preliminary data. But you also kind of want the reviewer to start understand what is the deliverables and what will be the overall impact. Bill was perfectly correct when he said, obviously the disease you're studying, let's say it's malaria, is very significant, but they really want to know, is the research you propose to do, even if it's on a significant subject, is what you're doing, is that really significant? And so this is what I think about when I'm trying to write a significant section. You want to emphasize the importance of the research and the gaps in current knowledge. And then you want to sort of start mentioning how your proposed research will fill these gaps, and hopefully to increase the impact, how the knowledge gained can be applied to other systems. So in other words, not just your particular, let's say you're studying cancer, how the knowledge gained may not just be applicable to the cancer you're studying, but to other cancers in general. The other thing you have to always think when you're writing a grant is from the perspective of the reviewers. And the reviewers on the panel will have quite varied backgrounds. Some may know your area of research extremely well, but other people may have very limited knowledge of it. So one of the key parts of your significance section is to bring the reviewer up to speed and provide essential background for the uninformed reader. You want to make sure that this background is focused just on your grant, so it must support the premise. And since space is always an issue, you try to avoid things that they don't need to know. But the key point is to get the reviewer interested and have them at the end of the significance section think, wow, this is a really interesting project. So some key points. Number one is don't assume the reviewer will read every word. So strategic highlighting and bolding can be helpful. Again, the reviewer may or may not have expertise in your area of research. So you have to sort of write it at a scientific American level, such that anyone who has a general knowledge of research can understand it. Make sure your statements are factually correct. I'm an infectious disease specialist, so one of the things that I find really annoying is when people make comments about the organism they're studying and it's not correct, when they say it causes certain types of infection when it doesn't. So you want to make sure they're correct. Try to provide the broad overall impact. And remember, this is sort of the sales pitch for your grant, because at the end of the day, when the reviewer is reading your grant, you don't want them to come to say, well, I'm pretty sure the applicant, the PI can do the work, but I don't really care. Why should I care about it, right? And so this is the key point, is you want to make them care. Some things to avoid. Avoid jargon and abbreviations. So again, if someone knows your area really well, then obviously they'll probably understand all the abbreviations you use. But on the other hand, if they don't know your area well, the abbreviations will make it extremely difficult to understand. So although you always are at a spaces at a premium, you really don't want to use a lot of abbreviations if you can avoid it. Obviously, you can use things like DNA and PCR, but other things. The other thing that I find really hard is if people, like in infectious diseases, if people are referring to different strains, different mutants, and rather saying, oh, this is the ABCD gene mutant, they just list it as a strain number, as AF230. And after a while, you have no idea what these different strain numbers mean. And the same thing goes for cell lines. So you want to avoid dense, hard to understand writing. A good friend of mine made the comment that if reading that grant gives the reviewer a headache, he or she is unlikely to give you a good score. So even though you might be be able to write grammatically correct English, if you have long sentences with subclauses, it makes it really hard to understand. The other thing is that, remember, on the study section, probably about a third of them, the people, English may not be their first language. So again, writing hard to understand writing, it just makes it that much more difficult for people to appreciate it. The other thing to avoid in the significant section is you don't want to start talking about pitfalls of your proposed research. You'll get to that later, but you don't already want to set up the reviewer to start thinking about weaknesses in your work. And the other thing you want to be very careful is to criticize other people's work. And I'll give you an obvious example. What if the person you're criticizing is one of the reviewers of your grant? So it's certainly reasonable to point to gaps in knowledge, and it might be fine to say things like unanswered questions are so-and-so, or whether this occurs is controversial. But you don't want to just say, so-and-so's work was fatally flawed because they can fail to consider this. Because again, what if that person or his or her, someone associated with that person is reading your grant? So you want to be extremely diplomatic. And typically what I tend to say is, well, the previous data, studies provided foundational information, unanswered questions include, and then go on and talk about it in that way, in a much more positive light. There's a few strategic points. Again, don't criticize previous work. Consider citing the work of potential reviewers and other influential researchers in the field. Again, as Bill pointed out, primary literature is better than review articles. Also, consider a diagram illustrating the system you are studying, the goals of research. That really, really helps. And avoid red-green color schemes. Use blue and yellow. So in general, about over half of the people reviewing grants are going to be men. We know that 7 or 8% of men have red-green color blindness. So if you use a red and green color scheme, you're seeing this with a red and a green. But if a person, and it's typically a man, because red-green color blindness is not very common in women, they're going to see this. And if this shows, your key data point, and the reviewer can't distinguish one from the other, that's pretty tough. So I try to use blue-green. We're Bruins anyway, as in my color schemes in my figures. Let me just mention about innovation. I think Bill has pretty much gone through this about what this means, but let me give you a few points. Is with the caveats is, you know, you want to try to avoid using standard tools to answer well-researched topics. So you want to try to, you really want to answer the question, and in a positive sense, does your research have the potential to have a broad, sustained impact on the field? When you write the innovation sections, remember it should just be one paragraph. Some people use bullet points, but the big thing that I see mistakes when I'm reading grants from junior investigators is it's a prolonged rehash of the proposed research. And it can be multiple paragraphs, but all they're doing is basically saying what they're going to do over and over. But the big point is you want to describe the overall impact on the field and keep this innovation section short. And with that, I'll stop.
Thank you very much. Let's go ahead and open the Q&A for this section. And now we're only 6 minutes behind, so you guys are very good at catching us up. And so let's see if we have any questions. I also want to mention there's some good information in the chat. I want to thank Kristen Leach for giving us the link for how to ask for an extension of your early stage investigator time. And she also had some reflections on doing this for COVID that you can read about. And then I actually put in the link at 9:44, the NIH announcement about the new review criteria that will be used after January of 2025. And so we have a year to get used to this. I kind of like this link because it maps the old criteria on the new criteria. So for people who want to learn more about that, which should probably be everybody on this Zoom, that's going to be an important document to look at. Okay, questions? No questions?
I'll ask a question if nobody else.
Okay.
The sort of comments on not criticizing previous work, but also showing how you might be filling a gap or using a new tool. Particularly in my research, I'm sort of laying out that I'm using a new tool, a wearable sensor to quantify motor. Is it okay, or the type of language to kind of weave around that? And majority of the study section reviewers would probably be people not using that new tool, who have laid the groundwork using standardized assessments, to say things like, previous research has laid an important groundwork for what we know, yet these are still the gaps.
That's exactly what you like to do. In fact, you can even say, if the person who did the groundwork might be on the study section, you can even call seminal studies, right? You know, it never hurts to compliment the person who might be reading your grant. But yes, that's how you would say it, as, you know, but unanswered questions remained, right? Or so.
Okay.
Because
and don't forget to do a lit search on all the names on the study section who might be in your field, because one of the things that guarantees that you're going to struggle with your score is if you left someone's seminal paper out of your bibliography. So it may sound petty, but take the time to, you know, look up the names of the people on study section and make sure you've cited their work if it's relevant for what you're doing.
May I ask just a quick follow-up question to that, Dr. Mangione?
Sure.
I know they often invite special reviewers for study section. That at least happened on my K, for example. And I'd imagine I would be citing those people anyway, because that's why they're inviting them. But how soon do you know? I guess it would be after you submit. So it would be, so it wouldn't, my question is sort of null to that. So, yeah.
I don't know. Are the invited reviewers? I'm going to ask people who served more recently. I don't think they're ever listed, right?
No, they are. I was trying to think of that very question. I think that the roster for the so they line up the ad hoc reviewers months in advance, and then they will post. I think it's posted at least about a month before. You will see the roster for that study section. And you can also see the rosters for previous study sections, and they mark the ad hocs, and they typically invite ad hocs about every other one. So you can get a feel for that. So you should be able to see who's on the study section before you have to submit the grant.
Okay, thank you.
You'll at least see the permanent members. You won't know who's going to ad hoc, but you can kind of guess. And, you know, as Bill mentioned, there's no limit to references, right? So you can kind of just make sure you cover all the big people and whether they're, you know, they may or may not be on the study section.
Thank you.
But the key point though for you though, is if you have a new technique, you think about when you write the significant section, your grant is you kind of want the reader thinking, wow, she has a really nice technique. I wouldn't mind learning that myself or using that in my research. This is really going to help. And they might even eventually talk to you and ask to collaborate or something.
That would be great. Thank you.
And I was just going to add too, I think there are times where you might say, you know, very little is known as opposed to no study has, you know, I would be very careful about those very extreme. I've read grants where people have said, no, nobody's ever done this, or this would be the first. And then
never say this will be the first.
Yeah. So just don't avoid those extreme statements.
Absolutely.
Other questions, comments? Roy, did you have a question?
Yeah, it wasn't really that important, but I guess if no one asked the question, I'll ask it now. I mean, it's part of the same discussion about like, you know, words to use or not use. So I say this half jokingly, but when I send my grants to my mentors, half of the edits are like changing from, you know, characterize to elucidate to confirm. So, you know, when we're trying to, you know, what words do you recommend we use?
Key thing is you don't want vague words like influence or something like that. You try to be more positive. I try to use more declarative senses. My mentor also really liked elucidate, for example, rather than characterize. I don't know if I review grants if I'm that sensitive. I do definitely agree about not using the word exciting because I, like others, have read grants where every paragraph had the word exciting and it became really unexciting to see that over and over again.
And I put in the chat, this is straight from the NIH, like how to write, you know, their writing tips, the verbs there, Roy, in the chat.
And, you know, 12 pages is short, but don't forget pictures and figures. Break it up a little for people. When it's wall-to-wall words, it's really hard to read that grant.
Right. And in that list that you put, they didn't have the word characterize there, Roy, which was one. And when I was training, my mentors took characterize out of the grants. It sounds weak, you know, determine, quantify. Those are great, you know. So.
Great.
Also, I find when I write, yeah, we were taught in the old days when we talked about writing sciences, everything was in the passive voice. This was done. I actually find it much more easy to read if you just put an active voice. So I typically say, we will do X, Y, and Z, or we will determine this. And I try to avoid the passive voice because I think it makes it easier to read and it sounds like you're more engaged with the work.
It also makes for shorter sentences, which with
Yes.
those of us who had to move from 25 single space pages to 12, like we expunged the passive voice right away because that was a good way to get, you know, more things in the space. Okay.
Right. And, you know, I recommended Strunk and White, and that's a big thing that they push is the active voice for clarity of understanding by the reader.
Okay. So it's great. We're only 4 minutes behind at this point. So I'm going to have us take our 5-minute break. Maybe we'll take 6 minutes. We'll be generous and come back at 10:20. And I believe Dr. Elashoff, are you up next? All right. So see you all in a couple minutes. All right, it's 10:20. So David, you want to take over the helm and put your slides up?
Okay, thank you. Okay, so I will get started with my presentation, and I will be focusing on the approach section of the grant application. I'm David Elashoff. I'm a biostatistician, and I lead the biostatistics program for the CTSI. Sort of jump right into it, going through some of the different sections of the approach section that you might describe. The first I'll talk about is the preliminary data section. And for each section, I'll really describe this as basically what is the primary question that the reviewers will be asking regarding the particular section. So for the preliminary data, the question might be, is there a reason to believe that the study hypotheses could be true? And is this research team capable of carrying out the study? So what are the necessary elements for this preliminary data section? As has been mentioned, strong and relevant preliminary data is key for an R1 grant, and it's going to be very heavily evaluated when considering the application. Some of the key things that are really important to demonstrate that you and your team have expertise with all the assays and methods that you're describing in the application, that the novel assays or methods work in the patients or samples that will be collected, and that you have strong support for your study hypotheses. I always recommend using figures and tables where possible, as that's going to have the largest impact on a reviewer rather than blocks of text. However, there's a number of sort of failure points that I've seen as a grant reviewer for many years. One is insufficient annotation for figures and tables. So every figure and table that you present should be essentially self-explanatory. That if it's a scatter plot, you should be able to read the X and Y axes of the graph and have those titles make sense in the context of what the reviewers are reading. There shouldn't need to be a lot of additional explanation provided. Another failure point are poor analytic data techniques. So if the statistical analysis is weak in the preliminary data, the reviewers might have concerns about whether the data that you will collect in the future will be analyzed properly as well. So it's really crucial to describe the analysis techniques that are used, but also make sure that they have a lot of rigor associated with them. Of course, if there is weak support for the hypotheses, that's a problem point. But some caution on unrealistically strong or naive preliminary results. So I do a lot of work in cancer biomarkers, and I've seen some applications saying that their blood-based biomarkers have 100% sensitivity and specificity for predicting cancer. Well, it's very unlikely to be true that this new biomarker has that strong performance characteristics, and that's likely to be a result of overfitting data rather than the true performance of a marker. Also, sort of this presenting a needle in a haystack result. So this is something that I see a lot also in the biomarkers world, where somebody might do, test hundreds or even thousands of different markers and present sort of only the one that looks like the best, and ignore the fact that they looked at a lot of things to get there. So it's important to be transparent about what you've done to get to your results, but also to be realistic that there may be some bias. Okay, so the next section is the study design. So the primary question that I would ask is the design of the study appropriate to address the study aim? So what are some of the necessary elements that we need to include? We start out with just what is the overall study design? Is this an RCT, a cohort study, a case control study, for example? What are the time points of evaluation in the study schedule, certainly if it's a longitudinal study? What are the endpoints that will be used to evaluate the study hypotheses? And particularly if these endpoints are at all novel, we would want to see details of how they'll be quantified and what the measurement scale is. It's crucial to describe the study population and any control groups that may be used. Include the inclusion-exclusion criteria will be important. And in addition to endpoints, any other study measures, we'd want to include those details of those measures with appropriate measurement process details, so we know how those measures will be ascertained. Okay, so within the study design, I always think it's really important to be really careful and very detailed about describing the existing population or the anticipated population. This should include relevant demographics, any prognostic or confounding measures. When I'm looking at a grant and I see a table that really describes the study population in detail, that really tells me that this is the investigators know what population they should look at, and if they have an existing one, that they know the relevant details of that population. Some additional considerations that are important to consider and include are randomization methods for clinical trials, validity and reliability of any study measures. The question of should subjects be matched or not matched, this can be somewhat of a complex issue, and I definitely recommend this is a point that a good statistical consult can help clarify. If there's going to be any prediction model building, we should include validation of those models, either with cross-validation or training test designs, or trying to apply the model to independent populations. Sort of what are some of the key failure points that I see? First is when the study population doesn't match the objectives. If we're looking for early detection biomarkers for cancer, and we're including stage 3, stage 4, late stage cancer patients in our population, that doesn't really match the objectives, and you may still find a result, but it may not actually be applicable to the intended use clinical population for your study. It's really important that there be really sufficient time for recruitment and follow-up, and if it doesn't appear that will be the case, if you haven't been able to demonstrate that you can actually recruit the population at the rate you would need to for your project, that's also a problem. It's really important to really clarify the availability of subjects. Does your team have a track record of being able to recruit subjects? What's the potential throughput of a clinic that patients might be recruited from? And in general, it's very uninteresting to read technical details of any methods or assays that are very standard. So if your team has published on assay or methods, it's referencing those may be better than providing a lot of detail, because you're just using space that could be better utilized elsewhere. Okay, so the next topic is the sample size, and the questions about what the sample size should be are the genesis of a lot of the consult requests that I receive. And so I'll kind of lead you through what are the things to think about here, but in general, the question is the sample size sufficient to give the study the ability to answer the primary study question? Okay. So the necessary elements for a sample size calculation, it always begins with the study endpoint. So whenever we do a sample size calculation, it's always based on a specific study endpoint. Say we're looking at overall survival, are we looking at quality of life? What exactly are we looking at in our study? We want to clearly describe the sample size that will be available for each aim. I usually recommend a separate power calculation for each aim, unless all of the aims sort of use the exact same study population. But if there are different endpoints in each aim, I would still write separate power calculations for each aim. Then for each study endpoint, we need to sort of build our sample size calculation on a foundation of quite a few different pieces of information. And the first one is, what is the statistical structure of the hypothesis? So typically you just in the aims you will describe what your scientific hypothesis is. But one of the things that's really crucial is translating that scientific hypothesis into a framework that can be statistically evaluated. And that translation from a scientific to a statistical hypothesis is really one of the sort of the first building blocks of a power calculation sample size justification. Once we've performed that translation, then we can consider what is the appropriate statistical testing procedure to evaluate that statistical hypothesis. So all power calculations will be based on a specific statistical test that will be used. Once we sort of have that foundation, then we need to answer some very specific questions about what our anticipated results might be for our study. So what is the effect of the intervention or the magnitude of the relationship? What is the amount of variability that we might expect to see in our outcome variable? So these two questions are going to be extremely specific to your particular research study. And they will be somewhat hard because often if you're doing something novel, we won't really know this ahead of time. If you're doing say, a novel clinical trial of a new therapy, you don't necessarily know how large the intervention effect might be. So this is a point where you potentially might rely on pilot data if you have it, rely on published literature in similar situations, or your sort of best guess. And then there's some technical components at the end. So what's the level of power, the level of significance, and is it a one or two-sided test? These are details that will be necessary to include in a power calculation, but are usually fairly formulaic. Some additional considerations when we're thinking about a sample size calculation: we need to account for study dropouts. If there's going to be multiple comparisons, multiple endpoints evaluated, we will often need to statistically account for multiple hypothesis testing. And one thing I often recommend is that it's often useful to sort of test it when doing sample size calculations. It's often useful to test out a number of different assumptions, say about the magnitude of the effect or the amount of variability, to see what that effect will be on the needed sample size for the study. So what are some of the failure points here? One is that if the sample size calculation doesn't have enough information for a reviewer to replicate. I can say that one of the things that I do as a statistical reviewer on applications is I try and replicate all of the sample size calculations, and if I can't, that is a problem. Another problem is if the sample size calculation doesn't use, say, relevant preliminary data that's been described in the application, or uses different statistical methods than described in the statistical analysis plan. So this is something where this calculation really has to be in alignment with the other elements of the application. Another thing that I see much more commonly now is, since there's a lot more emphasis on prediction modeling, machine learning, AI methods, that if we have a very large number of predictors relative to the sample size, this can create a lot of problems with potential overfitting, and it'll be quite important for the application to really address this, how potential overfitting bias will be handled. I'm going to go through just a few bad examples of power calculations and that I've seen, and describe why these are bad. So this first one, a previous study recruited 150 subjects and found highly significant results. So therefore, a similar sample size should be sufficient. So this is actually mathematically false, that that a prior significant result would imply that that same sample size will give you adequate power. So it's not actually the case. When I'm reading basic science animal studies, I usually see that something like this: our lab usually uses 10 mice per group, and that may be true, but it doesn't have any relevance in terms of whether that's the right number for this research study. 10 mice could be too many, it could be too few. It really depends on what the endpoint is and what the magnitude of the intervention effect might be. Another one is sample size calculations are not provided because there's no prior information on which to base. And this also may be somewhat true, that there may be a lack of preliminary data, a lack of real information to allow you to properly estimate a treatment effect, but that doesn't sort of release you from the obligation to, at the very least, describe what is achievable with the sample size that you plan. The next one refers to sort of the potentially eligible population, and this is very important to describe what the eligible population might be, but that's not part of a statistical sample size calculation that's supporting information. And the last one I see frequently is sort of a statistical power by fiat, where the authors describe that they do have power, but they don't provide any details. Okay, so I'll show a good example, and then I'll describe why this is a good example. So the sample size of 38 in each group will be sufficient to detect a difference of 5 points on the Beck scale of suicidal ideation, assuming a standard deviation of 7.7, power of 80%, assuming a two-sided significance level of 5% and a two-sample t-test. So a single sentence here. And then we describe that the sample size will be increased for dropout. And then the last sentence then is potentially leading into a longer justification for where did we come up with all these assumptions that are being listed in this sentence. So just to, as kind of a busy slide, but just showing that in this example, there's sort of, we're trying to hit on all the key points. We're mentioning what the sample size is for the calculation, what the magnitude of effect is, what is our outcome measure, how much variability do we expect to see, what is the power that we're going to achieve, what is the significance level, and what is the hypothesis test. So all of those pieces of information that I described in that prior slide can all be put together in a single sentence to describe what the power calculation was, the details of it. And then in the additional sentences describing what the enrolled population will need to be to achieve that sample size of 38 in each group, and what is a projected dropout rate. Okay, so the next section is the statistical methods. And so the primary question is, are the statistical methods appropriate for the analysis of the data that will be collected? So I recommend that a statistical method section be included for each aim, that we clearly describe analytic strategies for each endpoint. So if there's multiple endpoints in each aim, we should describe them all in that method section. The method should be appropriate for the type of data, if it's a categorical, ordinary, ordinal, or count outcome, and they should also be appropriate for the study design. Is it a cross-sectional study? Is it a longitudinal study, for example? Those will influence the statistical methods to be utilized. And we may, in this statistical method section, we may have a hypothesis testing component, but we may also have a model building component. Some things to keep in mind. These statistical methods should be appropriate for the sample size. So some methods are appropriate for small sample sizes, where others are appropriate for larger sample sizes. If we're going to include prediction modeling or regression, we should include evaluation and validation strategies in our method section. And particularly if we have human subjects data, it's crucial to account for missing data. Every human subject study will always have missing data, no matter how hard and diligent the investigators are. For some of the failure points in statistical methods, one is ignoring key confounders or demographic variables. I think Bill mentioned that sex was a biological variable. I'll mention it again, and I should probably mention it again later, because this is such an easy failure point. And if you ever forget to include this, reviewers will always remind you that you forgot to include it. So it's it's bold highlight, flashing lights, because this will always be a critique against you if you do not consider them. If also ignoring standard prognostic or predictive measures in models. So if we're doing looking at, say, biomarkers for lung cancer, we want to include smoking. It's pretty obvious, but reviewers are typically instructed to see what's on the page, not what they assume people will do. So if it's not included, even though it's obvious, the reviewers will ding you for not including the obvious things that should be there. One thing I see very frequently, particularly more in the bioinformatics world and now more in the sort of machine learning AI world, is really describing software that might be used to do the analysis, not really describing the ideas and the methods that are actually being implemented, and describing why those methods are really appropriate to analyze the data that's in front of us. So software may be important to mention, but it's really insufficient as a descriptor of what will be done. So we'll move on to a few writing strategies. So I think this was already mentioned by some of the other reviewers. Use the other sections as much as possible, the resources, human subject section, vertebrate animal section. In these, you can give details of the study populations, demographics. One of my collaborators has a fantastic vertebrate animal section where he creates a table with each sub-aim, describes the sample size for each sub-aim, describes the goal of each individual research project, describes the different experimental groups that will be evaluated, and describes the outcome measures. And it's all put together in one table in the animal studies section, and it really makes it exactly obvious what each experiment might be doing. Often those details, when presented in paragraph form in the approach section, can be a little bit hard to read, and it's a little uncertain exactly what will be done. Again, standard experimental methods should be referenced if possible, and that we want to avoid long blocks of text because reviewers will start to lose focus if the more they look at pages that are just wall-to-wall text with no figures or tables. As was mentioned by some of the other speakers, emphasize key points using bold, underlining, repetition. Reviewers will miss things, and that is just the nature of the review process. But you can, using some of these techniques, you can try and reduce the chance that they will miss some of the key points that you don't want them to miss. It's very frustrating to get back a review that says you didn't describe something when you clearly did, but trying to avert this before it happens by really focusing the reviewer's attention on what you can't afford them to miss. So some of the graphical displays that I think can be really effective: theoretical framework, experimental designs, aim flow charts, tables with patient characteristics and study measures. So I'll give you a few examples. So this was a grant that I worked on with Dr. Dubinet a few years ago, and it was developing biomarkers for lung cancer. And this was just the first aim, but as you can see, this was a very complex aim. We had two entirely different clinical scenarios. We were looking at smokers with suspect lung cancer and smokers who had actually been diagnosed with lung cancer. For each of these clinical scenarios, we had different study populations we were evaluating. For each population, we had different samples that were being collected, and for each sample, we had different assays that were going to be run. So this was an incredibly complicated study with lots of moving parts, but this one study really just put together a really great picture of exactly what was going to be done. And this would take multiple paragraphs to describe in text and probably leave the reviewers still scratching their head if it was just a big paragraph. But after just a really quick glance at this, you have a pretty good idea of what they're doing, and it's very easy to just go back and refer to a figure when you're reading an application, and you can find a figure much more quickly than you can find a block of text that might describe something. This was another grant application where I really liked the the graphic, this was an application by Dr. Vivek Sethi. And we were looking at the traumatic stress biomarkers and with the outcome of PTSD. And this combination figure sort of both described the theoretical framework at top, but then also described all the biomarkers that we were going to be looking at and showed sort of relevant preliminary data for each one of those. And again, seeing this in blocks of text would be incredibly hard to read, but a good figure like this can really put together a lot of information. For that same grant, we had multiple different time points, and so putting together tables of what things will be measured at what time points can be very useful. So the last thing I want to describe is that through the CTSI, there are a lot of support services available to faculty. And so with the biostatistics program, we provide free support for grant applications for study design, developing statistical analysis protocols, sample size calculations, and power analysis. We can also make suggestions about budgeting for collaborators and core facilities. So again, this service is free. As much time as it takes, our program will provide that help. But some suggestions is that it really is important to seek out help early with some of these components. And that's sort of important because sort of early lead time allows for multiple iterations of the development of the grant text, but also if there's not insufficient lead time, you don't really have time to integrate any suggestions. So if you might get some suggestions on sort of reformulating some elements of your study design, that's going to take some time to sort of flow through the rest of the application. Maybe it might affect budget in some way. So I very strongly recommend finding a statistical consult months ahead of the initial application. One thing that I see a lot is that people wait to get a consult, whether it's a statistical consult or a consult from other experts, until they really have the application well in hand, and they want to be able to present a fairly polished product when they're showing it to a potential new collaborator. And what I would say is that, I think the best opportunity for a collaborator to help you is when the ideas are still somewhat unformed, and where their experience and impact and knowledge can really impact things on your studies. So I'm always happy to meet with people when they might have some general idea of what their aims will be, but before they've even written much of the grant itself. So I think it's you should always sort of seek out that help as early as possible, and don't feel like you have to have a completed piece of work to seek out that help. Just the final thought that do this in advance, and that I've had an opportunity to work on hundreds, if not thousands, of grant applications at this point. And the one thing that I see that sort of works really, really the best is that proposals need time to sort of incubate, that you need to develop something, send it around for input from your collaborators, make changes, do that process over again. And the more iterations you can do before the application is submitted, the better product you can make. Many times somebody's first effort is not going to be their best one, and editing and re-editing and reformulating and rethinking about things is really a great way to develop a final product that is going to have a really strong showing. As Dr. Mangione mentioned, many times people are not funded on the first time, but that even with that the case, one thing that's really crucial is that you want the reviewers. The ideal case is you want the reviewers to have only small weaknesses that they identify in the first thing. Because if there are large weaknesses, they'll only focus on those and they may not get down to those smaller details. So a application that doesn't score well because it has major defects in the first round may never be able to make it to a fundable score in the second round because some of those smaller details may have been overlooked in a first review of the application. So that's the last slide for me.
Great. Thank you so much, David, for sharing your expertise with the group. I'm going to pass the torch to Scott Filler.
Yes, let me get this set up. Let me just say, having reviewed many grants and sat in on this grant writing workshop for many years, I can tell you that David's points about the power calculations are exactly right. And whenever I see people putting in the comments, the things that he said do not to do, I always chuckle and say, boy, what would David think about this? So I would definitely pay close attention to that. Let me share my screen here. There we go. Okay, so let me talk a little bit about the approach from a basic science standpoint. Basically, here's sort of the NIH criteria about the approach section. Are the overall strategy, methodology, and analyses well-reasoned and appropriate to accomplish specific aims? Have the investigators included plans to address weaknesses in the rigor of prior research that serves as a key support for the project? And have the investigators presented strategies to ensure a robust and unbiased approach? So the big thing is, and then the other question is, again, potential problems. Are potential problems or sort of strategies benchmark for success presented? If the project is in early stage development, will the strategy establish feasibility and are particularly risky aspects managed? And have they, again, presented adequate plans to address relevant biological variables, such as sex, in the study of vertebrate animals or human subjects? So those are sort of the general thoughts. But the critical thing, I guess, is how do you first lay it out? So the majority of people who write grants will have their approach as sort of the following layout, which is I'll present their preliminary data first, and then do aims 1, and then aims 2, and aims 3, or however many aims they may have. This is sort of the standard approach. And if your aims are relatively similar, and the preliminary data are applicable to both aims, then that's fine. However, sometimes people will have aims 1 and 2, for example, that are pretty different. One of the weaknesses of this current approach is typically by the time you get to aim 2, you actually rehashed some of the preliminary data to remind the reader why what's the basis of aim 2. So an alternative approach that can be more space saving is to put your preliminary data for aim 1 in aim 1, then you don't have to rehash it, and the preliminary data for aim 2 in aim 2. So in other words, your preliminary data section is split in 2. And this could sometimes save quite a bit of space if you're short of space. Probably a key common weakness of grants are the preliminary data sections. Remember, you want to present compelling preliminary data that supports the premise of the work, hopefully demonstrates the feasibility. In other words, if you're going to show that you're going to be doing certain assays, that the preliminary data demonstrates you can do the assay. But the other thing you want to do is you want it to spark interest, but leave the reviewer wanting more. One of my collaborators has told me, just because the data are in your lab book doesn't mean it has to be in the grant. And because you don't want to give so much data that the reviewers think, oh, you actually already know the answer to the question. And then all the stuff you're doing is sort of dotting I's and crossing T's. So you want to give enough data so they know you can do the work. But again, you don't want to give away the punchline. So the potential pitfalls in preliminary data that I see are clear weaknesses in the data, Other things are no statistical analysis. I hate it when I see graphs that don't have any statistics, so I don't know whether it's or significant. Probably the worst is when I see graphs that have no error bars, because you think, well, what does this really mean? And another thing, of course, is the PI says the data support one hypothesis, but it's also an alternative hypothesis could be equally well supported, and that's not addressed. So you got to make sure that when you present the preliminary data, that it's really helpful. So basically, you want to actually, let me get back to this. Another thing about the preliminary data that you can do that can save you a lot of space is I put a fair amount of detail in my figure legends about the assays that I did in terms of what I did, the time points, and so forth. Because then you can refer to that. You can say, we will do this assay as in figure 2. You don't have to bother giving all the details because it's already in the figure legend. And typically, when you write the figure legend, you can use a smaller font. But per NIH rules, the regular body of your grant should be written in 11-point Arial font. But I typically use 9-point font to write the figure legends. So you can put a lot of information in the figure legends without using too much space. So in the approach section, the critical part, I think, is describe the overall approach and the controls and mention the key details. As I think David has mentioned, you want to put power calculations for the animal studies. But again, many details of the animal studies can be moved to the vertebrate animal section, again, saving you space. You always want to address sex as a biological variable. And as I think he mentioned, I actually make sure I underline the heading for power calculations and underline the heading for sex as a biological variable, because these are both score deriving issues. And if you don't address them, it's very easy for the reviewer to dock you for not having these things. And so if you just write them and they're just written in a paragraph without any bolding or underlining, sometimes reviewers can miss it and say you didn't have it. And it can be really irritating when you actually did, but they didn't see it. Let me see potential pitfalls that I've seen from reviewing grants. Probably a key common early mistake is one aim depending on another. People tend to write grants really easily, both for the basic science and also in the health services research, where one aim depends on another. The problem with this is that if your first aim fails, then your second aim clearly can't be done. So you really never want to have one aim dependent on the other. I put an asterisk by it because sometimes one aim will be 100% certain to fail, like you're going to just collect data, and then in aim 2, you're going to analyze the data. But in general, you really want to avoid that. Another thing that I see when I review grants is excessive details, because clearly is what you really want to know is what is the person going to do and what assays sort of are they going to use? And you can reference the assays, but you don't want to talk about, well, I'm going to be doing, adding 5 microliters of this to 10 microliters of that, stirring for 30 minutes and so forth. Because number one is the reviewer will just skim it. And so you basically wasted your space. And the other thing, it's a target of criticism because they might say, well, how come you're doing this at pH 7? It should be at pH 7.4. Well, obviously you'll figure out the correct pH and you don't want to give this as a target for criticism. The thing I find when I review grants from early career investigators is they frequently, you can tell by the level of detail how confident they are in the methods. So if it's an assay that they've done frequently, you'll see the detail will be very minimal. But if it's something they haven't done, they give you excruciating detail, somehow thinking that giving a lot of detail will convince you that they were able to do the assay. Whereas instead, it's actually better just to use the same level of detail in all parts of the grant. And I think it's been told to you over and over, really avoid densely written prose. I try to put a space between paragraphs. I actually still use indentation. Remember, if reading a grant gives a reviewer a headache, that grant is unlikely to receive a good score. In fact, is what some of my collaborators do and I try to do is typically, if you have all your preliminary data in graphs at the front of the grant, it means the last part of the grant is just going to be text after text. So I constantly try to put a table or a graph or something near the end of the grant. So when the reviewer is starting to get tired of reading, they think, oh, good, this page isn't as long because at least it has a graph or a table in it. So a key part of writing the approach section is anticipated results and potential pitfalls. So obviously the anticipated results are, what do you think the results are going to be? Creative and flexible thinking are very, very important. And you really want to think about alternative outcomes. I think that a really common problem that I've seen when I review grants from early stage investigators is they'll talk about technical potential pitfalls, but they never talk about the obvious one, which is, what if the hypothesis you have is not supported by the data? So what you want to try to do with your alternative outcomes is take a page from the software industry and make a bug into a feature. In other words, I try to think of an outcome that may not support my original hypothesis, but might actually be more interesting than my original hypothesis. So if I got that, I would tell them this is the direction it would send my granting. So again, a key thing that you want to mention is what to do if your hypothesis is not supported, because it may not. Obviously, if you knew your hypothesis would be supported, you wouldn't need to write the grant. Another key point is you never present a potential pitfall for which you don't have a good solution. So I can give you an example. I was reviewing a grant that I didn't know the subject matter all that well, and I was reading it and I was thinking, wow, this is quite a good grant. And then they put in the potential pitfalls, a major pitfall. And they said, oh, we're going to handle it this way. But their approach to handling the pitfalls was extremely unconvincing to me. And as a result, I ended up giving the grant a poor score because of this pitfall that they had pointed out. Or if they hadn't pointed it out, I would never have known about it. So remember, the reviewer will be plenty happy to punch holes in your grants. You don't need to give them more ammunition. So you only prevent pitfalls for which you have a good solution. Another one of my pet peeves is grant after grant that I've read, almost always the potential pitfalls has a variation on the following sentence. The investigative team has substantial experience with this work and thus do not anticipate any technical problems. I find this to be just a waste of time because people say this over and over again. And I almost look at it as a show of weakness, because hopefully your preliminary data will be so compelling that it will clearly demonstrate that you have the experience in the work. And if you don't anticipate any technical problems, you don't have to say it. Hopefully it should be obvious. And in my view, putting in this sentence just wasted a line of text that you could have used for something more interesting. So again, I think the key point for writing the approach section is to make the potential pitfalls really interesting and exciting. I also try to add into that section the future directions. So they go, where is this going? What will be the impact? And how can this big information learned be applied to a broader question? So I think when you write your potential pitfalls, you should also even add in future directions. In other words, why is this important? Because again, you don't want the reviewer to say, well, I'm convinced the PI can do the work, but I'm not sure I really care to know the answer, right? And so that's why you want to know. And with that, I will stop.
Great, thank you. Now we're pretty far behind at this point, but I think both you and David shared a lot of important information. So I'm going to propose that we skip the Q&A and go right on to the two talks about how to write specific games. This is such a critical section of grants, so I want to make sure that we do those two talks. And then we may proceed on, Scott, to have you go ahead and talk about what you do briefly when you're not funded. And then whatever time we have left, we'll use for Q&A at the end. So Tannaz, you're up.
Hey, great. So let me share this. And okay, so let's jump right into specific games. I'll talk fast, see if we can make up some time here. But I have to say, this is my most favorite part of the entire proposal. Again, this is, let me see if there we go, we're advancing. I think arguably the most important section of your application. We've talked a lot about the approach, and for the 3 reviewers who are going to read all 200 plus pages, the approach obviously is very important, as it is for the study section, but the entire set of reviewers are likely to read. This is like the 1 page I think everybody reads. And so you really want to write this early. You want to circulate this. This is, again, where you start, and I think where you will end. And this section has to include everything. It's kind of daunting. So you have to include everything that's important and exciting. Don't use the word exciting, but not with a lot of detail, right? This is like your, we always talk about elevator speeches. This is like everything you want to highlight. And again, getting folks excited about it. You've got 1 page, so it's really valuable real estate, and everyone's going to read it. So we're going to talk about, I think, sort of a best practice for your intro paragraph, sort of capturing attention, this hook, gap, critical need format that you can consider. The second paragraph, really a logical next step, what the proposed solutions are that you and your team are thinking about. You then go into the aims, and then a final summary paragraph. And I'll come to number 4. I feel like a lot of specific aims that I read often forget to sort of tie it up with a nice bow at the end. And so don't leave your reviewers hanging after you talk about your aims. And style, again, this is really non-technical. I used to say no figures are allowed. I think actually you can include figures. Technically, you might actually see an error, but it's one that you can bypass. But I would suggest avoiding figures. Again, real estate is very important on this 1 page. And again, something that everyone is going to be taking a look at. So in terms of this, the approach for the first paragraph, so the hook, gap, critical need, what you want to do in the first 1 or 2 sentences, obviously, is grab the attention without using the word exciting. But what is this proposal about? Why is it important? Again, maybe referencing the strategy for the Institute, reports, care guidelines, and again, emphasizing impact. So how many millions of individuals, for example, might be affected. Then you want to really try to highlight what's known in about 3 to 5 sentences. And again, being very concise, just enough to educate the reviewer. And then really go right into the gap. So what is the gap? What's the knowledge deficit that your research is going to fill? And then really closing it with the critical need for your study. So we want hypothesis-driven sort of knowledge, technique, treatment, et cetera, that you're going to develop, how this, as an example, addresses an important problem or a critical barrier to progress in the field. And again, should be this logical setup, this first paragraph for the rest of the specific aims page. So this is an example and really something that you can consider. And I guess maybe in the interest of time, I don't want to go through it and read it word for word. But again, the hook is, we know there's strong consensus, but despite this widely sort of accepted, endorsed, there are these gaps. And here's where, there's a critical need. If we can figure out a way to solve this problem, we're going to save billions of dollars, or we're going to improve health for X number of patients. So your second paragraph, again, is the logical next step. So what is your team's path towards this project? So you can mention, again, prelim studies, not too much detail. And then I think it is very important, again, for health services, where we often have large multidisciplinary teams, to talk about the expertise that your team brings to this critical gap or this critical area of needed research. You want to obviously think about including hypotheses and rationale, the main objectives of the proposal, and then again, the team's qualification. So these are things that you might include in that second logical step paragraph. So this is an example here. So again, we hypothesize that blank intervention will dramatically reduce pre-op testing for cataract surgery. Okay. And then we propose to test this hypothesis by conducting a pragmatic randomized trial, implementing our intervention at, and then sort of fill in the blank. And this will naturally help you transition to the aims. And that is on our next slide. So your aims, again, keep the number reasonable. 3, I think, is pretty typical. We've seen up to 5. Beyond that, again, there will be questions regarding feasibility. Each aim needs to really have a dedicated sentence. It needs to be concise, concrete, and really clarity is the goal here. It's up to you. Some individuals like to, as a style, to state their hypotheses for each aim. Personally, that's not the way I write my aims, but I've seen it go both ways. And so there's no right or wrong here, but just think about, again, all of the information that you're trying to get across in this one page. But it is very, very important that each aim does describe the approach. It's really clear about what you're trying to test. Seems realistic in terms of the time frame. Again, feasibility, there's a definitive outcome. And I think the last bullet point here about it not absolutely being dependent on the success of another aim is really an important point. And I've seen many proposals sort of get lower scores because, you know, aim 3 really depends on whether or not aim 2 works. You want to try to avoid that as much as possible. So as an example here, again, there's 2 different examples. So I'll just sort of walk through the first one. So we're going to integrate a 2-pronged behavioral economics intervention into the UCLA Health EHR. The intervention will include 2 types of behavioral nudges to promote the desired reduction in low-value care, and then you sort of explain what each of the nudges are. And then there's a second example here. And the second example, I think, is one that we see quite often, where you have an aim with sort of a primary outcome, and then there are secondary sort of sub aims, which I think are important to think about as well. And then sort of this final, so you've done your hook, gap, critical need, the second paragraph, the aims, and really the final paragraph. Please don't forget about this. I can't tell you how many specific aims I've read where, again, they sort of, people list the aims and then that's it. And you just sort of feel like you're left hanging there. So a few sentences to get the reviewer, again, excited about your proposal, and really thinking about this as like this hourglass, right? You start wide, you get narrow a little bit more into the details with the aims, and then you sort of end with this broad base. So talk about innovation, what's new, and what the impact and the payoff will be. You really want to end on a high note here and sort of bring it all together. So on this slide, we have an example of sort of a final paragraph. So I'll read maybe the second one. So electronic health records, EHRs, are in their infancy, and we as scientific community are only beginning to learn how to use them as tools to promote desired care processes. This proposed pragmatic trial would break new ground in our understanding of how behavioral economics approaches can be used to tamp down on care that does not promote better patient outcomes. So again, very broad statements. As you think about the rest of your proposal, do remember to go back and refer to your specific aims throughout the approach section. You want to reiterate your aims. Again, conceptual models are very important. And I've seen really nice examples where the aims are actually also illustrated as part of the figure for the conceptual model. Again, consistent terminology is essential throughout. And I'll just say too, I think this is the last slide. This is a link to kind of the resource on that hook, gap, critical need description, which I think is really nice. And a reminder here again with this infographic that there are different reviewers or people who are going to be very excited about the work that you're proposing, and people who are going to read the first few sentences and kind of have, well, we say reviewer number 3, the less positive initial impressions. But I think the specific aims is your opportunity to really make the case for what you want to do and why you and your team are the best. And then the last thing I would say is you've heard me say this a few times today. I'm a health services researcher. I read basic science specific aims all the time for colleagues and send my aims to them. So I think actually having folks who know very little about your science and your focus, they can often give you the best feedback. If they understand your aims and they're sort of convinced that this is kind of a neat proposal that you're putting together, an important question, then I think you've done your job of sort of convincing folks who might know nothing about your work. So definitely this is something that I would suggest even sharing beyond the team and with folks who have 5 or 10 minutes to read it and give you feedback. So I'll stop there. Thank you.
Great, thank you so much. And we'll pass to Scott for your talk about aims, and then you can just walk right into your talk about what you do when you're not funded. And then hopefully we'll have some time for some Q&A at the end.
There we go. Yeah, so the key thing of the SWIC aims, as Tannaz very nicely went over, is this will determine most of the reviewer's score. So you want to convey your excitement and you want to make the reviewer want to read more. But the key point is you want to make sure that it tells a coherent story, that it isn't a set of disconnected paragraphs. You want it to have a consistent narrative that goes through the entire page. So as Tannaz mentioned, the typical layout is 1 to 2 paragraphs of background, importance of the topic and your overall goal, prior research, especially your own, gaps in the current knowledge, and then the overall hypothesis. So the aims are typically in bullet points. And then after that, of course, you end with your importance and the impact of the knowledge to be gained. So a key thing about this is it must be easily understood. And so this is what typically goes on in the study section. Typically, when they call up a grant to get reviewed, first the reviewers will be giving their initial scores, and then they'll start talking about it. First, reviewer 1 will go through what the grant's about, strengths and weaknesses, followed by reviewer 2 and 3. So during this time, the other members of the study section who will probably not have read your grant or know anything about it will call up the grant. It will typically be reading the SWIC aim page. And remember, people will have very different backgrounds. As an example, I was a member of the AIDS opportunistic infection and cancer study section. So in this study section, we reviewed grants based on opportunistic infections in AIDS patients, ranging from virus infections to parasite infections to fungal infections, and even grants related to cancer that was in AIDS patients. So you can imagine a cancer biologist would have to be able to read a AIM page and vote on a grant by someone who is like in virology or someone in mycology like me. So you want to make sure it's really understood. So Tannaz's point about giving it to people who don't know your work and having them read it is really, really important. So you want to tell a clear story. And because you want it to be easily understood, you want to avoid jargon and abbreviations. You want to use simple declarative sentences and hopefully provide a clear description of what you hope to do, and the key knowledge gaps will be filled. In general, the SWIC aim page, when the reviewer reads your grant, will probably really start forming or shaping his or her opinion of your grant. And so it's really, really important to have a strong SWIC aim page. You want to, again, things to avoid: jargon and abbreviation, dense, hard to understand writing. You don't want to ever put in potential pitfalls of your work. You can get to that later. You just want to be on a positive. You want to avoid criticism of others' work. Again, you can certainly focus on gaps of knowledge, but you don't want to directly criticize the work. And it was already mentioned, you really don't want one aim to depend on another. I am part of the committee that reviews KL2 grants, and I can tell you there are multiple grants that we saw where one aim depended on the other. So this was a pre-review, and hopefully our eventual grants that we review won't have that flaw. So things to do: make sure that the research will address your hypothesis. Occasionally I've read grants where the research, they had an interesting hypothesis, but the research that they were planning to do wasn't really going to address the hypothesis. And again, have people outside your field read the aims and make sure that that they can understand it. And with that, let me stop. But I think I'll move right on then to what to do when your grant isn't funded. So let me go this one. So while I'm calling it up, let me just mention that, part of being in academics is to have grants that are not funded. One of the study sections that I was a member of basically had almost an unspoken rule that they would not fund a grant the first time. So if you put in your RO1, it virtually always got rejected the first time. Hopefully it would get scored, but it would be rejected. And then you put it in the second time, and then it would get in. There are other study sections that don't do it that way. I think I read that the NHLBI, for example, they actually, to avoid resubmissions, have a higher funding cutoff for first submissions than the second. But so it depends. But no matter what, if you're in research and put in grants, you will probably get them rejected. And so this is sort of what to do when that happens. There we go. So the key thing is what to do when this happens. And if you think about it, for your average grant, you might have spent 6 months working on it, getting the team together, poring over it, have other people read it. This is your baby. And then you're found out that your baby is ugly because it did not get funded. And so the way to sort of think about this is sort of what is taking a page from Elizabeth Kubler-Ross, who wrote this classic book called On Death and Dying. And so when you find out that your loved one has an incurable illness, this is what you typically go through: stability, immobilization, anger, denial, bargaining, and finally acceptance. And frankly, this is what we all go through when our grants get rejected, right? First off, anger. These guys are idiots. How could they have not seen my brilliance? To depression. And then hopefully finally acceptance. So when you go to write your rebuttal letter for your grant, you don't want to write it here, because remember, the key thing is whenever you write your grant, you have to think about it from the purpose of the reviewer, right? This is a poor person who had to read probably 9 or 10 grants. Typically, as was mentioned, they could be hundreds of pages long. They're trying to also keep their own research going. And they made their best analysis of what was good with your grant and what was bad, and your grant didn't quite meet that bar. And so showing anger and just saying this person is stupid is not going to help you. So you want to write your rebuttal letter when you're in the acceptance phase here. And it's also important, if you're worried that hostility might be coming through in your letter, is have other people read it and make sure that it doesn't sound hostile. So here's sort of the point. This is sort of the process. When you find out that your grant did not get a fundable score, the first thing you want to do is contact your program officer. Typically, they will say you'll get the score first, and about anywhere between 1 to 3 weeks later, you'll get the critiques. Don't bother contacting the program officer until you get the critiques, because most of the time they'll just say, well, let's go over the critiques first, but you have to read them. So you want to have read the critiques closely yourself. Then you contact the program officer, and typically is what you want to do is set up a telephone call, maybe a Zoom call, but definitely not email, because the program officer will tell you many things over the phone or via Zoom that they would never put in an email. And remember, don't shoot the messenger. The program officer is not the one who reviewed the grant and has nothing to do with the critiques. So you may be very frustrated with the critiques, but don't take it out on the program officer. You want the program officer to remain your friend. Then you want to read the summary statements closely, especially look at the resume and summary of discussion, and look for common themes. When you write your rebuttal letter, you only have one page. And so what I try to do is look for common themes. Clearly, if if at least two reviewers, even three, had the same concerns, those concerns are absolutely critical to address. If it's just one person's concern, they need to be addressed, but they're not as important. So here are some common fixable problems: poor writing, insufficient information or experimental details or preliminary data, weak premise or significance, and approach not shown to be feasible, but applicant can demonstrate feasibility, or insufficient discussion of potential problems and alternative approaches. And this last one is the weaknesses I see in early stage investigator grants over and over and over again. So this is a key thing to not do, because this is easily fixable. Things that can be difficult to fix are philosophical issues, like the reviewer believes the work is not significant. That can be a heavy lift to go through. My hypothesis is not sound or not supported by the data presented. Again, you can fix this, you can get better data, but that could be a challenge. The work has already been done. I mean, you know, we've all been scooped over our time. The worst sometimes is you submit a grant, and then in the time between when the grant was submitted and reviewed, some key paper comes out, which is, you know, basically someone just did your aim one, and it certainly happens. Proposed methods are not suitable for testing the hypothesis, or the investigator environment are poorly suited for the proposed work. The environment, since we're all at UCLA, is almost never a problem, but the investigator can, and especially the key thing is that the reviewers are going to look at the investigation's publication record. And so they're going to want to see the investigators published papers in the field, and hopefully has been publishing papers at a reasonable rate and no recent gaps in work. So for example, it would be a big problem if the investigator says, I'm going to do this nice grant, but you look at their CV and they have no published papers for the past 3 years, for example. So you clearly want to keep a steady publication stream. So again, the rebuttal section, it's one page long. You can briefly summarize the major criticisms. Now, the one thing is the reviewers who review your grant the second time will likely consist of some of the people who had reviewed it before, and usually one person who hasn't, one or two people who haven't. They will get the previous critiques, which they will read, but they will not get your previous grant. But the one thing that you can easily try to do is frame the criticisms in a positive light, right? Like, you don't want to say the reviewers felt they were unqualified to do the proposed work, but instead you put it on a much more positive light, which is the viewers felt that additional expertise and statistical analysis would strengthen the project. And this could be fill in the blank. It could be any other type of thing that they thought would be helpful. Remember, some of the same reviewers will likely review the revised version. One of the criteria, a scorable criteria, is, has the person been responsive to the previous critiques? And that's something they comment on. So the one thing you want to do is make changes if they're reasonable. But remember, some changes that they want you to do may not be reasonable. And if so, then say why. So, you know, we've all had experiences where you put in grants where we change something in regard to what a reviewer said, and then we've put in the next grant to the revised version. We're actually criticized for putting in what was suggested by a reviewer. So in other words, if the change they suggest is unreasonable, respectfully state why, and then stick to your guns. But in general, if it is reasonable, make sure you do the changes. Be polite. I'm giving you some quotes that I have actually read in rebuttal letters. One would be the reviewer is just plain wrong and this grant was not funded. Whereas if you say, we respectfully disagree, this grant may be funded. And so again, always remember when you're writing your rebuttal letter, remember the viewpoint of the reviewer. And hopefully the reviewer was not hostile and was just trying to do their job. And so your rebuttal letter should be positive and should not be negative, should not be accusatory or hostile. So then to summarize, keep your tone positive, try to convey commitment and excitement. An easy way to do that is mention that you now have additional data or hopefully new publications. And again, have someone else read it to make sure that it's not hostile. So final thoughts is make sure your resubmission is the best possible. So you want to hopefully maximize your preliminary data and publication. Have other people read it. There's only one resubmission allowed for the current grant. So in other words, it goes from having a number to then like O1 to an A1. However, if your second grant is rejected, the second time you put it in, it's still rejected, you're allowed to resubmit it. You just have to give it a new name. So you can keep the same grant. The other thing about it, though, is when you resubmit a grant for the third time, you are not allowed to put in a rebuttal letter. But remember, though, that the reviewers who reviewed your previous grant will probably still be reviewing the grant. So if they suggested changes, you should still make those changes, because otherwise they'll give you the exact same critiques that you got on the previous version. So what happens if you submitted your R01 two or three times and you just can't seem to get a fundable score? Well, there's a couple. One thing you can do, of course, is ask yourself, is this the right study section? Talk to the program officer and see if maybe you should try giving it a new grant, a new title and a new abstract and moving it to a different study section. I've seen that working. The other thing is what if it turns out that the reviewers always liked AIM 1, for example, but just hated AIMs 2 and 3. Then is what some people have done is submitted that AIM that the reviewers liked as just an R21. Granted, you don't get anywhere near as much money, but getting some money is a lot better than getting no money. And so with that, I will stop and be happy to take any questions.
Great. And thank you, Bill and Tannaz have been answering questions in the chat and really appreciate that while we're listening to your talk. So now, we have about 30 minutes left. And I want to open up the floor for anybody to ask questions about any portion of what you heard today. As you can guess, these are pretty seasoned panel here, many people who've served on study patients, and it is no overestimation to say that David Elashoff has worked on thousands of grants. I know this personally from watching him work over the last 3 decades or so. And so, yeah, please fire away. And the questions in the chat have been good. I think at this point, I believe they've all been answered, but go ahead. Any questions for any of us? And, again, introduce yourself, turn your camera on, and tell us who you're aiming your question at. We've stunned you. Okay, there's a question in the chat. Lisette, do you want to ask your question? Why don't we go with that one first?
Thank you so much. It was such a excellent and beautiful presentations, all of you. I'm actually at Charles Archer University, and so I heard about this workshop, and so I'm grateful to be here. So my question is for Dr. David Elashoff. Did I pronounce your last name correctly? I hope. But basically, I had a question regarding the figures and how do you decide, or what's the best method to decide, like when it's best to communicate, like you said, in the visual figures instead of using the long paragraphs.
Yeah, I mean, as much as possible, I would use figures. Obviously, you want your pictures to say 1,000 words. You don't want your pictures to say 1 sentence. So I have seen people use large figures that only show one thing. And if you're, so it's, it's a hard question to give you a general answer to, but I think when you're presenting your preliminary data, particularly for your first R1, having a visual representation of what you're showing can be really valuable. Even if you're going to state it again in the text, because then again, it's sort of that repetition. People will see it from a few different points of view, and some people learn more by reading, and some people learn more by seeing. So I think you can do both, particularly if it's sort of a central piece of your preliminary data. You can do both, and I think it's very valuable to do both. But for sort of showing sort of the design features of your study, I really think having the more figures and tables, the better, because if you just there's so many things that can be better portrayed in a table or a graph.
Great. I'm going to jump in. Lisa Chan, are you still in this meeting? Oh, good. She's put it in. So we mentioned the CTSI grant library a couple of times, and that's been a real labor of love. It's taken many of years to pull it together. And I asked Lisa to put the link in for anybody who would like to request access to the grant library. So thank you, Lisa. I see you put it in. And Rosalind, do you want to ask your question?
Hi, thank you so much. This has been really informative. I'm curious. I had started typing on the chat, but I'm curious in terms of rebuttals and if you shape your rebuttal specifically to the reviewer comments, and by the time you've resubmitted, you have a different set of reviewers, and is it possible that the new set of reviewers have a critique or even like a different critique or even disagrees with what you have redone in your grant, and how would you address something like that?
Sadly, that happens. So most people serve a 3-year term on study section. So you could easily have 30% of the people in the room be different people than who heard your original submission, proposal. And so hopefully one of your primary reviewers is still in the group. I think that the executive secretary tries to line things up, so that would be the case most of the time. But it's fair game on the resubmission for the committee to raise issues that might not have been raised in the previous review. So for those of you who've served on study section on our panel, would you like to add anything to that?
Sure. The instructions from the NIH are to treat a A1 application, a revised application, as a grant in itself. You do look how the person responded, but you're reviewing that grant. And as Carol said, you'll most absolutely guaranteed that you're going to get new reviewers that may bring up concerns that the previous study section did not, and that is part of the game. So,
I think to not be completely demoralized by this, one of the things I would say is if you do a really good job addressing the concerns, especially if a concern that's brought up during the A1 or the first resubmission is something that could be addressed pretty simply. Sometimes, your primary reviewer might step in, or your secondary, and say, well, Dr. Brown did such an amazing job answering all of our concerns, and this one looks kind of small. And I imagine that if we raise this with her that she would probably gladly address it. And so you can, sometimes you'll hear the conversation go that way instead of saying, oh, we've got this new little concern, so let's reject this grant. I mean, everything is kind of taken in context. And, I think the important thing, remember what Bill said about who's on study section. I mean, it's people like us. We have a lot of mentees. We know, to make someone go another 9 months or go another resubmission or rename the grant as a new A1, that's asking a lot. And so I don't think you see people really reject on the second time unless someone's done a poor job of addressing the original concerns, or if something is recognized as a real deal breaker for the science. And so, a real serious flaw that was somehow missed on the previous review. But I don't know what the others of you have experienced. I mean, every study section has its own personality.
In my experience, I served on actually 3 NIH study sections in my career, so I'm clearly a masochist. That a revised application that got dinged for people recognizing new faults, it does occur, but in my experience, that was a rare event. I'd say for the most part, and it was data that you showed, Carol, that revised grants do better as a population. And
they're more in the 35 to 40% success rate.
Right. So their success rate is above the pay line. So
I mean, the one thing that I would say along the same lines is that typically, let's say you have 3 aims, and the critiques focus a lot on aims 2 and 3, but no one commented all on aim 1. When I resubmit, I never change an aim that they didn't comment on, because I figured I could actually make it worse instead of making it better. So if they had no comments on aim 1 except or only laudatory comments on aim 1, then I don't change that aim at all and only focus on the aims that they criticized. So that, unless of course I suppose you had some new data. But I generally figure if they liked it, then they probably will. But of course, we've all had it where suddenly an aim they thought was fine on one submission, they didn't like the other. And that's just part of the game, basically.
Yeah, I mean, I think being like a laser beam on the criticisms and not, you may have in the interim thought of a much more interesting way to address the problem. Just don't go there, because, the thing that's really important about grants is grants are not contracts. And science moves forward. So if you get this grant and then all of a sudden there's a better assay or a better approach to the problem, you talk to your project officer and you get permission to use the new assay, and it doesn't go back to study section. So everybody acknowledges that things change, right? But you just don't give people more arrows in their quiver. Like, just hang tight with the concerns, do your very best job addressing the concerns.
I agree completely. And when revised grants do not make it, it's typically because the reviewers not say that they got worse, they just say the grant is not improved.
Right. So Roy, you want to ask your question?
Yes, thank you so much. So this is an open-ended question, just your general thoughts as far as the inclusion of exploratory aims, since it's more susceptible to, pitfalls in statistical analysis. And I did appreciate the comment of potentially maybe repackaging that into an R21, but as far as I understand, the acceptance rate of an R21 is comparable, at least for new investigators, compared to an R01. So thank you.
Yeah, Tannaz, Scott, you want to take that one?
You're right. If you look at the success rate of R21s, they're the same as R01s, but the criteria in which they're reviewed is different, right? Because in an R01, sort of the rationale, if you think about it, if you're applying for an R01, you're applying for a grant that's probably $1 million+ dollars. So basically, they want to de-risk it. So you have to have pretty strong preliminary data. But an R21 is supposed to be exploratory. So you don't need anywhere near the level of preliminary data for an R21. They say you don't need any preliminary data, actually. But and as a reviewer, you're not allowed to ask for additional preliminary data. But in general, I think I have never seen an R21 accepted with no preliminary data at all, but you need much, much less. And so clearly an exploratory aim would fit very nicely in R21, whereas it might be viewed to be too risky for an R01.
Yeah, and I mean, I agree. I think including maybe a sub-aim that is exploratory or hypothesis generating, but not for an R01 as a main aim, I think that would be very detrimental possibly to the score. The other thing I'll mention too is that some of the institutes, I know NIDDK, they have these new like smaller R01 mechanisms. So the requirement for preliminary data is lower. So the budgets are smaller. They're still called R01s, but they're smaller. We haven't had many people apply for them. It's relatively new, but that might be another thing to look out for. But I think generally for exploratory, the R21 is probably your best bet.
And so in my opinion, it's just a little bit different. As a reviewer, I actually have a soft spot for exploratory aims, even in an R01. If it's really smart and very well justified by other parts of the grant. But I would say overall that the bulk of reviewers, they want preliminary data to strongly support every aim. And that will be the, for lack of a better word, the safest R01 approach. So.
All right, other questions? You guys are such a quiet group. Go ahead, please.
Yeah, so I wanted to ask, when you resubmit a grant, imagine that you made an aim and then you feel like maybe you just don't want to have that aim anymore. Can you just delete one aim and resubmit, or that would not be considered resubmission?
Well, I think especially if you get the concern raised that your scope is too ambitious for the funding, that sometimes it can be quite strategic to drop an aim. But what do other people think?
Yeah, I definitely agree with the sort of the dropping the aim. I think one of the most common things I see on a new investigator is having maybe too many aims or trying to do too much with the grant. So, you know, taking something out that's has received a lot of critique, or you don't have a lot of preliminary data yet for, you know, you can always, you know, divide up an existing aim into two pieces if you feel like you still need to have sort of three aims in your by taking one out you've lost it. But I think there's, you know, there's a lot of overambition and in early applications, and having a really focused project that's doable is often going to score well.
Or if your grant is not felt to be overambitious, they think that the scope is fine, but they really don't like one of your aims, it's certainly feasible just to get rid of it altogether and swap it out and put in a, you know, come up with a new aim.
Thank you.
Okay, Rosalind?
Yeah, hi. I wanted to follow up on that question. I was curious if, you know, by the time if you have a substantial time between your resubmissions, if some of the aims have actually especially sub aims have already been completed, do you just move that to the preliminary data and state that, you know, these aims have been completed?
All of us are nodding yes.
Yes. Yeah, because it shows that you were working on the project in the time, and that's a big plus.
Yeah.
Especially if you publish a paper on those data in the interim as well. Yeah.
One of the best responses I ever saw was where they had something that was critiqued heavily, and then they said, well, we've actually now completed it and published it, and so it's no longer part of the project. So
yeah. Right. As reviewers, we really like that.
Rita, you want to ask your question?
Yes, please. So let's say in the grant, you are going to propose something that you've built upon some preliminary data, but now introduce also maybe a new technique to add to yours. So I have motor data, we have EEG data, and now I'm going to see if there's, you know, some relationship to describe brain processes associated with the motor data. I'm not an EEG person. We haven't published together, but we have some preliminary data, and that person, EEG expert, will be on the grant. Is that okay, or should we have published on something prior to the R01?
If you have the data and the people, sounds good.
Yeah, that's what I was gonna say. I don't think it's a requirement that you published with everyone. It's nice to show the relationships. And you know, you could say we've been working on this together for X number of months, but I don't think there's a requirement. I agree.
Thank you.
But the one thing you can, I mean, number one is with luck, even if they're a collaborator or a co-I, you can actually get a letter from that person, you know, saying they're going to work with you. But that's clearly what most happens. If you look at almost all R01s, you almost never see just a single investigator, because a team can, you know, beat an individual almost every time. And almost nobody has the expertise to do everything in an R01. And so almost all R01s have co-investigators. So that's kind of expected. And so if there's an area that you don't have the expertise in, that's exactly why you get someone to do it. And hopefully someone with acknowledged expertise, and that her or his, you know, biosketch will demonstrate that type of expertise, but in terms of publications that person has done.
I also want to bring up something I don't think we mentioned, which is the multiple PI mechanism. So, you know, if you have a complex and ambitious project that really requires pretty equivalent expertise in two different areas, or if you have a scope of work that's just, you know, such that it would really help a lot to have two PIs, like imagine you're doing a multi-center study and you're recruiting patients at two different sites, and you both contributed equally to writing the grant, and you know, you have collaborated before, and it's going to be in the best interest of the project. Don't be afraid to use that mechanism. If you're early stage investigator, you lose your early stage investigator status if the other person isn't also an early stage investigator. So if you have two early stage investigators with unique contributions, you can go in MPI and you can both get credit for being early stage investigators. When you go up for promotion in the UC system, MPIs are treated like PIs. And so you both get credit for being a principal investigator on a major grant. If you go in as the PI with a co-PI, those co-PIs are treated like co-investigators. So they're not going to get the same level of credit when they come up for promotion. So, you know, if something truly is the intellectual property of two individuals, and you're bringing unique expertise to the table, I think study sections look quite favorably on MPI grants. Jeffrey.
Hi, everyone. Thank you so much for this session. It's been really terrific and so helpful. I'm Jeff Hsu in the Division of Cardiology at UCLA. Quick question about kind of publications as in prelim data, given the delay in between the submission period and the review period. Sorry for the dog in the background. If we have a publication that gets accepted, in the meantime, is there a way to kind of update the study section on that new publication in that few month interim period?
Yeah, you'll be contacted by the SRO with an email that goes out to everyone. And I do believe that's one of the things they allow. You don't get to submit supplemental data, but definitely a publication. And that's about upwards of 2 weeks before the study section, I think is the limit. But the email will come like 6 weeks before or something like that, automatically generated.
But they're
So
pretty strict. Typically, you're only allowed to give the title of the publication, basically the reference to it. You're not allowed to give a long, description of it or anything.
Yeah,
Right.
you're not allowed to attach the manuscript.
Okay. But that's fine.
There's a question in the, Juliana, before we go to you, there's a question in the chat asking about how do presentations at national conferences compare to publications for early stage investigators? Obviously not the same, but is it 50% is good, 5% is good? So what do you guys think about that question? Anybody can take it.
You have to have the publications. The meeting presentation is fine. It shows that you're out there interacting and networking, but you have to have the publications. So I would go.
It's a little bit of a red flag if you've got 100 abstracts and 20 podium presentations and no publications.
Right.
It raises questions about whether you're a finisher. It raises questions about, well, maybe when that work went under peer review, it actually didn't pass muster, and so they couldn't figure out how to get it published, or so that's like red flags shooting up all over the place. So podium presentations at national meetings do show that you're in the community, you're productive, you're generative, you're interacting with people, but you got to have publications. Now,
the one thing though that the NIH has recently allowed is you can list something that's in bioarchives as a presentation. As a publication.
Right.
So in other words, you can just write the paper and submit it to bioarchives at the same time you submit it to a journal for peer review. So to show publications, you're allowed to list bioarchives and things in bioarchives or other repositories as publications.
So I'm going to take this question, then I'm going to go to you. There's a question about MPIs. I've heard that early stage investigators should be very careful with the construction of their MPI plan, as you want to convince the reviewers that you have a solid plan in place to navigate the inevitable complications that come from having more than one cook in the kitchen. Reaching out to a colleague mentor who have been MPIs on other projects to find out what went wrong, what was challenging, in a good way is to know what to address in your MPI plan and convince the reviewers that you're ready to handle it. I feel well positioned to answer this question because I've been an MPI 7 times in the last 15 years. And what I would say is you have one page to explain why you're using the MPI mechanism and what your plan is going to be to resolve conflicts. And so yeah, you have to use that page. But I think, obviously, if you've been an MPI once or twice before with the same person and it's been great and you've been very generative, nobody has any concerns about you being an MPI. If you're, a lot of times in health services research, and I've been MPIs with people who are health economists, who clearly are bringing expertise I don't have to the project. We're very clear on who's going to lead on which aim. We're very clear on what we're going to do with senior authorship. Like a lot of times we have junior investigators on the project and we'll say, we're going to rotate the senior authorship position every other paper, or we're going to, be senior author on the one where we had the biggest contribution. You have to have a conflict resolution strategy. And so what we usually will do is list a senior person in the field who's at UCLA but has nothing to do with the project, and who we both agree on when we're writing the grant is a fair-minded person who would judge us both equally, and that person becomes the tiebreaker. And so it's not like, it's one page. You don't go on chapter and verse about this stuff, but they're going to want to see how you're going to manage authorship. They're going to want to see who's doing what. We're going to want it to be really clear who the contact PI is. And on some of my MPI grants, we rotate contact PI every other year. On other ones, we just make one of us the contact PI. So, I've seen it work both ways. So I think it's okay. I have not seen in my experience as a reviewer or as a scientist, things go down because they criticize that we used an MPI mechanism. But others on the call, what do you think?
I think it's a good thing to do.
Yeah.
The other thing that I try to do in my bio sketch is if I have publications where both of us were authors, I try to make sure those end up in my bio sketch so the reviewers see that we've actually worked together before.
Yeah, and I think that I agree. And just don't forget the bio sketch paragraphs too, though that's another place to highlight relationships, history of collaboration. And I think sometimes we overlook those. So also a good place to highlight some of that.
Great. Juliana?
Yes, thank you. This has been really informative. Thank you so much. I have also an MPI early stage investigator related question. I'm currently in my second year of the K, and I was hoping to preserve my ESI for my main line of work. However, I have a collaboration with a colleague from a different institution where we considered submitting an R21. We actually submitted one, and it was rather well scored. But then the PO came back to us and saying, you should really submit this as an R01. This is, way underfunded. It's a great idea. Just scale it up. And this is the better way to go. However, we both are early stage investigators. And so I was thinking if I should rather be protective of the ESI to use for my own primary line of research, or if it actually doesn't matter and it's a good problem to have to be funded at all, even as an MPI, even though it is not my primary focus. And I wanted to.
Yeah, this depends on how much this grant is not your primary focus. So if it's really not your primary focus and you've got preliminary data and you really, want to be writing your own R01 6 months from now and you want that ESI bump, then what I might suggest doing is, being a co-investigator on the other project. And if it's really the other person's main line of research, let them be the ESI person. But if it was truly your line of research, there's no downside to using your ESI as an NPI, especially if it's going to give you those foundational papers and set you on a trajectory. One of the best things about writing your second R01 is having been highly successful with your first R01. So, if you are an MPI and it's a really great project and it's really in the direction you're going, I think that's a good use of the ESI status. But if it's really kind of a left turn or a little side project for you, I wouldn't use it for that.
Got it. Thank you so much. I appreciate it.
Do others disagree with that?
I think another consideration I was thinking when you were asking is the timing. If both grants are being submitted at about the same time, then definitely save the ESI for your grant. If your grant is a couple of years down the road, then go for the safer one and go for because the other consideration is you want to get grants.
Right.
And so if you're going to be an MPI on this grant, are you going to split the budget and how much money are you getting? So that's a consideration as well.
Got it. Makes sense.
Thank you. The other sort of point is I've watched many young investigators start out in one thing, but they ended up sort of following the grant money. And although they envision themselves going down one path, the way the grants can't find it, they end up going the left turn. And so although you look at this as a left turn, you never know if this was what you could get funded in. This might not becoming the main research line. So you're going to have to decide that on your own.
Yeah. And turn to you're in a K award right now in year 2. I mean, discuss this at length with your mentor because your mentor probably has a pretty good feel for the likelihood of success and impact of your main thread, compared to this. And so I think somebody who's more familiar with your work can give you the more nuanced advice. I'm going to be respectful of people's time here. We're at 5 after, and I know some of us have other meetings we need to run to, but this has been really a pleasure. I want to thank my colleagues who are here on the Zoom with me, who I agree gave really great talks today. And I want to wish you all the very best of luck as you're making the K to R or any kind of career development transition to being an independent investigator. It's a big step, Our CTSI has a lot of resources and infrastructure to help you make that step successfully. So, you know, you were smart to come to this workshop, but also look on the website at all the materials that we have for people writing grants. There is a tremendous amount of help that you can get with the administrative aspects of the proposal, the budgetary aspects, the scientific aspects. And so, you know, I think I put the link in the chat to that part of the website where you can get help with grant submission, grant reviewing, et cetera. And so wishing you all the very best. I hope that you are, you know, writing impactful and exciting work, and that this process that looks really daunting and is really daunting isn't as bad as you think once you get into it. So take care.